Через YouTube. Так, arıyoruz. Все. Все. Gözümüzde. Все. Uğurlar olsun. Tamam gel.
Yo otursun qoy.
Tamam.
Yo yo mən.
Okey ben çıkarım. Ben dersim var. Seni kaydetsin. Uğurlar olsun önce.
Bir tane langi gittiğimiz polemize.
Ama yazar.
Tamam.
Öz sivilimizde ben de yazarım.
Beynəlxalq workshop keçirdik. İndiyanı.
Nəinki yay məktəbi, hətta workshopda keçirdə bilirik.
Защита, onu bilirsin. Başına bırak, защита eləməmişəm. Söz verir. Üç dəfə söz verir, inanmıyorum. Bilir, yalan bir şey. Ben yemek pişenden sonra ne yapayım?
4-ə kimi.
Oy, birinci yılda kimi astıracaqsan?
Ev yox, bəlkə tez qutarar.
Alo. Ha.
Sevda xanımı səndən eşitmək istəyir aslında. Deyim ki, inşallah məndən də yaxşı çürəkən sizə xidmət edəsin Allah. İndi yazarım qəzdən. Qoy, daha da belə eləsən, qanatdansın.
O görmeyecek. O güneşen dedi. Şuraya gidiyorlar. O bak onu görmeyecek. Onlar da baba ikilenden ikinci oğlan doğma. Ben de benim doğmuş. Kıtlama 751'de. Biz iki tip atsanıyız. Zannediyor. Yeni kadınların nefes şeyi.
Qoy, biraz şey eləsin, daha da yumuşalsın.
Sen o telefonu değil, ben ödeyeceğim yok Sevda Hanım, o yala ver. Ben bu ikinci oğul doğmalıydım. Sen o güneşten olmalıydın.
Çok əlləşmədən.
Yox, yazdım.
Var. O zaten çürəşən.
Millətin hisslərlə oynayır. Mən dəhşət psixoloji şey.
Anne, teyze var bile çürəşən. Anne,
Yox.
gelecekte.
Zəps eləyim. Başlayanda zəps eləyim.
Zəb şeylə başlayanda YouTube-da da qalır olsun. Linki mənə göndər, YouTube linkini mənə göndər. Hamıya göndərdim mən. Gözə bir nəfər.
Hardan göndərin?
Ayda. Bəyək kopyalamadı.
Kopyaladım. Hə, burada var, şeydə var.
Nasıl?
Burada var. Tipsdə atmışam çata.
Mənə də göndər, WhatsApp yazarlar.
Sən chatda görə bilərsən də, sən bu chatı.
Mən verəcəyim, bax mən sabaha gələcəm.
Elviz, sənə hara göndərim mən bunu?
WhatsApp-a göndər, ayda.
WhatsApp-ımı açmamışam axı.
Hə, şey okey, mən taparam da, narahat olma.
Gir bax, çıx sonra da. Gir linki götür sonra çıx.
Göndereceğim. O linki burada paylaş. Bu
Niye?
Ben ayrılmışım. Kapalı bağlı değil mi? Sen hiçbir şahsi görmezsin.
Hala şahsiye var.
Burada akarat
Ne oldu ki?
onun için yani değil mi? Boş şey değil.
Bir göster.
Sen gönderirsin. Hiç ödemem.
Ha, indi yoxlaya bilərəm burada.
Çata göndermişim şeye.
Bilirəm, burada yoxlaya bilərəm. Özüm yoxlaya bilərəm YouTube-da.
Bunu paylaş.
Bilirəm, burada yoxlaya bilərəm. Özüm yoxlaya bilərəm YouTube-da.
Good afternoon, Father.
So very good afternoon to all of you.
Good afternoon,
Good
Father.
Good afternoon, Professor Rafiq. So very good afternoon to all of you.
Good afternoon to
Good
everybody.
afternoon, Father.
Good afternoon, Professor Rafiq. So very good afternoon to all of you.
Good afternoon to
Good
everybody.
afternoon, Father.
Good afternoon, Professor Rafiq.
Father, can we start?
Yes, please go ahead. It's 3 p.m.
Okay, Father. So good afternoon, all of you. On the occasion of centenary celebration, Azerbaijan State Oil and Industry University Baku, in collaboration with St. Xavier's College Autonomous Kolkata, is organizing a 2-day international workshop on high performance computing application AAHIPC 2020. On behalf of the organizers of this international workshop, I, Dr. Topolina Bhattashali from St. Xavier's College Autonomous Kolkata, and my co-host Dr. Elviz Ismayilov from Azerbaijan State Oil and Industry University Baku, would like to extend a warm welcome to all the dignitaries and participants present here. Due to various constraints in the year 2020, once we thought that it would not be possible for us to organize this workshop from our side. However, we are here today only because of the person who is none other than our principal, Reverend Dr. Dominic Savio, SJ. Father always says go ahead for any new ideas to motivate us. And he never says no for anything, for any new idea. So Father is truly a dynamic leader. We are really blessed to have him among us. We are really honored to have our principal as keynote speaker of AAHIPC 2020. Reverend Dr. Dominic Savio, SJ, Principal of St. Xavier's College, Kolkata, and the President of St. Xavier's College, Calcutta Alumni Association. He is blessed to be named after one of the famous Catholic saints, Saint Dominic Savio. Father was also the rector of St. Xavier's Community College and School from December 2013 to January 2020. Father is also blessed to have got Jesuit education all through his life, right from his kindergarten days to his PG studies. Father did his schooling from De Brito School, a Jesuit school of high reputation at Devakottai in southern Tamil Nadu, and graduated with major in economics from the famous St. Joseph's College, Trichy. He did his post-graduation and MPhil from the epitome of Jesuit education in India, Loyola College, Chennai. He received his PhD in economics from Bardwan University. His research interests include international trade, international economics, econometrics. Father joined the Jesuit order in Dhyan Ashram, Kolkata in 1985 and was ordained as priest in 1996. He did his higher studies in philosophy at D. Nobile and Jnanadeepa, Pune, and theology in Vidyajyoti, Delhi. Since the year 2000, Father is associated with St. Xavier's College, Kolkata in teaching economics in its arts, science, commerce, and BBA departments. He has been the vice principal of the Commerce Morning and the BBA departments of the college, and then the deputy principal and subsequently as the principal of St. Xavier's College Autonomous Kolkata since 1st November 2017. Apart from being a member of the governing body of many Jesuit educational institutions, he is the convener of the Calcutta Jesuit Province Higher Educational Commission. Father Dominic Savio is the vice president and secretary of the governing body of St. Xavier's College Autonomous Kolkata and the governing board member of St. Xavier's University Kolkata. He is also the governing body member of the Goethals Indian Library and Research Society. He is the president of the managing committee of St. Xavier's Collegiate School, Kolkata, St. Lawrence High School, and St. Paul's School, Raghavpur. He is also the vice president of the governing body of St. Xavier's College, Bardwan, and the vice president of the managing committee of St. Xavier's School, Durgapur. Father is also the governing board member of the International Association of Jesuit Universities. Reverend Dr. Dominic Savio, SJ, was conferred Lifetime Achievement Award during the Deepali Roy Memorial Award 2019 ceremony at the Church of Epiphany, Thakurpukur on 11th January 2020. Father was conferred the Mother Teresa International Award by the International Award Committee on 16th January 2020. The award was handed over to Father by the Honorable Governor of West Bengal, Sri Jagdeep Dhankar. He is the recipient of the Award of Excellence in Education and Philanthropy conferred by Bengal National Chambers of Commerce and Industry on 14th April 2018. Reverend Dr. Dominic Savio is the recipient of the prestigious Maulana Abul Kalam Azad Award for his contribution in higher education in 2017. He also received Asia Pacific International Educational Award, Bharat Vidya Ratan Award, and many more. Father has elite publications in both national and international journals of repute. Father has edited a book and presented papers in several higher educational institutions and in national and international seminars and conferences. Father delivered a number of international lectures in various prestigious places all over the world, like International World Jesuit Congress, World Assembly of Jesuit Universities. Father has already proved himself as a true Jesuit by way of his strictness in achieving competence among the students, including discipline in one hand, and being extremely compassionate towards his students when any of them has been in distress or in need, any guidance, help, comfort, and counseling. Now, I will invite our principal, Reverend Dr. Dominic Savio, SJ, and Chief Patron of AAHIPC 2020 to deliver his keynote speech. Over to Father.
Thank you very much, Dr. Topolina, for your kind words and long introduction. It's also very good afternoon to all of you. Respected Dr. Mustafa Babanil, Rector, ASOIU Baku, Dr. Rauf Aliaro, Vice Rector, Professor Rafiq Gamlau, and all other respected faculty members of Azerbaijan State Oil and Industry University Baku, St. Xavier's College Autonomous Kolkata. Once again, a very good afternoon, a very warm welcome to all of you for this first international seminar after signing MOU. On the occasion of the centenary celebrations of Azerbaijan State Oil and Industry University Baku, this international workshop on advanced applications of high performance computing AAHIPC 2020 has been organized. The aim of this workshop is to explore the impact of HPC applications in multidisciplinary fields of modern society. AAHIPC 2020 is the first international workshop partnered by St. Xavier's College Autonomous Kolkata with your institution after the signing of the MOU on 16th December 2019. Due to the COVID-19 pandemic, this workshop has been organized in online mode. Although we are facing several difficulties in the year 2020, COVID-19 teaches us to find out opportunity in every difficulty. We can now understand the utility of online mode. It enables us to reach beyond boundary. In the offline mode, it may not be possible for all to physically participate, but an online provides us with this great opportunity. This is the centenary celebration year of ASOIU. Despite of our worst fears, we have supported each other, encouraged each other, and have stood together. This type of workshop is expected to foster research interest among the students as well as faculty members, and they can exchange ideas. This reminds me of a famous quote by Henry Ford. Quote, "Coming together is beginning. Keeping together is progress. Working together is success." High performance computing refers to the practice of aggregating computing power in a way that delivers much higher performance than one could get out of a typical desktop computer or workstation. In order to resolve real-life problems in multidisciplinary fields, HPC can process data and perform complex calculation at high speeds. It is essential for any project involving large data sets, complex simulations, and rapid calculations. In today's data-driven world, high-performance computing is emerging as the most usable tool to gain deep insights into diverse fields like genomics, computational chemistry, financial risk modeling, and seismic imaging. due to its direct relation with the data analytics. HPC is now gaining attention and spanning its application areas. It becomes inevitable in any fields like economics, sociology, linguistics, law, where large data sets are being used. Environment that thrives on the collections, analysis, and distribution of data and depends on reliable systems to support streamlined workflow with immense computational power. Need HPC, whose focus is on the building capacity and capability. HPC is also now being used in industry to improve products, reduce production cost, and decrease the time it takes to develop new products. High-performance computing systems are used to develop software in a wide variety of domains, including nuclear physics, crash simulations, satellite data processing, fluid dynamics, climate modeling, bioinformatics, and financial modeling. HPC has been vital to analysis of cancer genomics data, both for providing the necessary computational power and the security needed for handling sensitive patient genomic data sets. It can also be used to develop flood warning systems for river basins, urban modeling, drug discovery, design and development of direct contact liquid cooling systems. Investment firms can use HPC to predict stock trends and trade with millisecond timings. Banks can use it to improve fraud detection and reduce lending risks by getting a deeper profile of their applicants. Hence, the aim of this workshop is multi-dimensional. I am very happy that this meeting point has been organized between the two institutions. On behalf of the rector, myself, and all faculty and students of St. Xavier's College, Kolkata, India, I wish all the faculty and students of Azerbaijan State Oil and Industry University, Baku, the very best at this proud moment of your centenary celebration. The world is aware that your country again suffered the ravages of war with Armenia over Nagorno-Karabakh. We are grateful to God that finally truce has been announced with Armenian forces withdrawing. Let your celebratory flags grace the every surface of your land, especially the martyrs' alley cemetery on the hillside overlooking the Caspian Sea. I wish to conclude by saying peace is more than just the absence of war. True peace is justice, true peace is freedom, and true peace dictates the recognition of human rights. In a special way, I would like to thank all the important administrators of the university for taking initiative to have the MOU with us. Surely, once the situation is normal, surely we'll be able to visit each other's institution to have more and more exchange programs. Let us wish each other, may there be God's grace on our land forever. Thank you very much. May God bless us all.
Thank you, Father, for your inspirational speech to motivate us. Now I would like to request my co-host, Dr. Nigar Ismailova, to introduce their Vice Rector of ASYU. Nigar?
Thank you, Tapalina. Thank you, Dr. Savio, for your hot presentation, for your hot introduction. And I want to introduce the gratitude you and your colleagues from the St. Xavier's College for the helping us, for the working with us in the organization of this workshop in this significant period for our university and generally for our country. And now I want to introduce you our Vice Rector on International Affairs, and who is also the administrative coordinator of the MOU of the collaboration between our universities, our organizations, Rafik Jamalov, to introduce you our HPC politics of our university, and also to greeting for you, Professor Jamalov.
Thanks, Nidar. Dear Dr. Dominique Savio, thanks a lot for your warm words and support in our struggle. Respected participants of the international workshop on advanced application of high-performance computing, as Your Excellency, Mr. Principal mentioned now, this workshop takes place on the days when we celebrate the centenary of our university and dedicated to this date. Therefore, I would like to give you a short information about our educational institute. Our institute was established 100 years ago as the first technical school first technical university in the world in the field of oil and gas. There are 16,000 students from 30 countries studying here. We have more than 600 faculty members and researchers. We have more than 100 university collaborations with about 50 countries. Our university has joined partnership programs with governments and universities of the United States, France, Germany, Italy, Norway, and others. We are an active partner for the European Union Erasmus program. Since 2 years ago, in accordance with the set of activities carried out in the field of development of science and knowledge in the Republic of Azerbaijan, in view of the country's long-term plan to increase the role of scientific products and implementation of industrial projects, the university has developed and implemented on access to HPC. The university has gathered knowledge of HPC systems and consequently has established the Advanced Research Center for Computing and Forensic Power Systems. The main goal of this research center is to acquire knowledge of the design and management of high-performance computing systems to meet the scientific and industrial needs of the Republic of Azerbaijan. The development of science, as well as the creation of large industries, has enabled the university to establish a center for analyzing the existing needs in the Republic of Azerbaijan. As one of the main goals of the Advanced Research Center, HPC University, is to provide services to industrial centers of our Republic. It is currently providing services.
Professor, your microphone is muted. Please.
It's not more fault. Okay. Could you hear me?
Yeah. Yes. Thank you.
Yes. That's not more fault. That's technical. In the case of the Azeri Space Research Center, in addition to providing computational services, model development services are also on the agenda. Concerning the Center for Climate Research, as well as the negotiations, in addition to implementing climate models, there is also the potential to develop the climate model of the Republic of Azerbaijan. In addition to activities undertaken, training of specialized human resources in the field of high-performance computing systems is also underway. This ensures that in addition to acquiring knowledge, native experts of the Republic of Azerbaijan can produce knowledge or meet industry requirements in the field of high-performance computing systems. Students that train and work on the HPC Advanced Research Center of the university are able to meet the needs of the industrial centers of the Republic of Azerbaijan in the HPC. A specialized journal of HPC systems is also being published. This journal published in HPC systems using an expert editorial board. So far, 5 editions of this journal have been published. We are currently negotiating and communicating to include its name in the International Index Center. Selected papers submitted to the workshop also will be published in the next issue of Azerbaijan Journal of High Performance Computing, dedicated to the 100th anniversary of the university. Besides, HPC Center is registered in international systems, different international systems. According to the goals of HPC Center, it's possible to continue cooperation with St. Javier's College in the following areas. Finding markets that need HPC systems, and according to the development plan of the university, can use the computing and processing capacity of the university to implement existing scientific and industrial programs in India. Then, another main goal of our center is to design scientific and industrial programs. And we'll try to produce scientific and industrial software that requires high computing in the Republic of Azerbaijan. The 2 universities can work together to design and produce software, as well as find new markets in which there's a need to design software that requires HPC. Exchange of professors and students and definition of start opportunities between the Advanced Research Center and the university. I wish the workshop participants fruitful work, and thank you for your attention.
Thank you very much, Professor Jamalov. Now I want to ask my colleague Tapalina for introducing as the Dean of the International Affairs for the inaugural address.
Thank you, Niga. Now I would like to request Dean of International Studies and Programs, St. Xavier's College, and General Chair of AAHIPC 2020, Dr. Panchali Sen, for delivering her inaugural speech. Without her continuous support, it is not possible for us to organize this event from our side. Dr. Sen is currently graduating from St. Xavier's College, Kolkata, and then went to complete her MA in Political Science from Calcutta University, securing a first class. Subsequently, she worked on her PhD thesis, The Role of the Non-Aligned Movement in the Post-Cold War Years, 1990 to 2000, and has been awarded the degree by Jadavpur University in 2007. She joined the faculty at St. Xavier's College in 1993, a former head of Political Science Department from July 2009 to June 2013. She is also the coordinator for the Human Rights and Duties Education course supported by the UGC. Currently, she is also functioning as the academic coordinator in the MHRD GOI project on public administration with the Educational Multimedia Research Center, EMMRC. She has participated in various seminars and has a number of publications to her credit. Her areas of interest and teaching include international relations, comparative politics, political sociology, and public administration. Over to ma'am. Ma'am, are you there?
Thank you, Tapulina, for introducing me. Respected Dr. Mustafa Babunli, Rector, Azerbaijan State Oil and Industry University, Baku. Dr. Rafiq Jamalov, Vice Rector. Dr. Rauf Aliyarov, Professor Ehsan Musavi, Dr. Nigar Ismailova, Reverend Dr. Dominic Savio SJ, Principal, St. Xavier's College, Kolkata, India. All other respected patrons, advisors, committee members, and students from both the institutions. Wish you all a very warm afternoon. Today is a wonderful moment for St. Xavier's College, Kolkata, India, and Azerbaijan State Oil and Industry University, Baku, as collaborative partners in organizing this international workshop on advanced applications of high-performance computing, AAHIPC 2020. The aim of this workshop is to explore the impact of high-performance computing applications in multidisciplinary fields of modern society. The field of application of HPC is extremely dynamic and evolving, thereby demanding an assessment at frequent intervals. It is with this focus in mind that the two-day workshop has been organized. There are 4 invited lectures over the 2 days. We have invited lecture 1 today on statistics, concepts and controversies to be presented by Dr. Oyun Chandra, the member secretary of our academic council in St. Xavier's College, Kolkata, and invited lecture 2 on challenges of using live process migration in distributed exascale systems by Professor Ehsan Musavi from Azerbaijan University. Tomorrow, which is day 2, we have invited lecture number 3 on challenges of influence, dynamic and interactive events on resource discovery functionality in outside of distributed exascale systems by Professor Araz Aliyev from Azerbaijan University, and invited lecture 4 on advanced symmetric key cryptography algorithms by Dr. Ashok Nath from St. Xavier's College Autonomous, Kolkata. There are also paper presentations in various sessions where students and professors from both the institutions will present their research work. On the centenary celebration year of your university, I extend my heartfelt congratulations to all of you at Azerbaijan State University. We are looking forward to active participation from both the ends in making the workshop a success. I wish to conclude by highlighting words of Martin Luther King Jr. Peace is not merely a distant goal that we seek, but a means by which we arrive at the goal. I pray for the peace and well-being of all faculty and students of both the institutions in the hope that the COVID-19 pandemic, which has disrupted our lives in more ways than one, is something which is transient and cannot prevent us from achieving that goal. I wish all of you, both at Azerbaijan and all of us here at St. Xavier's, the very best for the 2 days of academic activity. Thank you so much.
Thank you, ma'am, for delivering such wonderful speech. Now I would like to invite our first invited speaker of this workshop, Dr. Oyun Chandra. Statistics is the discipline of collecting, analyzing, presenting, and interpreting data. It is the base of all the terms that we are using in various fields like big data, data science, analytics. That is why we are starting our session with the expert talk on the domain of statistics. Dr. Ayan Chandra is teaching statistics at St. Xavier's College, Autonomous, Kolkata since the year 1999. He is currently the member secretary of Academic Council of the college. He has also been the head of statistics department from 2011 to 2014. Dr. Chandra has published many papers in various national and international journals. He has also presented research papers in many national and international conferences. He got the Best Application Paper Award in International Conference on Operations Research held in Tirupati in December 2014, and also got the first prize for paper presentation in National Workshop on Medical Statistics and Clinical Trials held at Pune in December 2010. Many students have successfully presented papers in Indian Science Congress under his guidance. He delivers lectures at Bose Institute as an expert for PhD coursework. Dr. Chandra has been awarded his doctoral degree in statistics with specialization in operations research. His area of interest is operation research and biostatistics. Now, I would like to invite Dr. Chandra to deliver his expert lecture on statistics, concepts, and controversies. Over to Dr. Ayan Chandra.
Thank you, Dr. Paulina. Good afternoon, dignitaries. In the first place, I'd like to express my gratitude to the organizers for giving me this opportunity for presenting a paper here. Now, the theme of this conference or webinar, obviously in these days, is data, computation. When we think of data, obviously we are really flooded with infinite amount of data. So how to process them, that is really a big challenge to all of us. But when we process the data, we need to understand how should we process the data. That means actually what kind of tools that we will be using. That will depend on the nature of the data and as well as the analysis that we want to carry out. So my title of my talk today will be Statistics, Concepts and Controversies. I am presenting my screen now.
Volume reduce करो. Escape.
Can you please confirm whether you can see the PowerPoint screen?
Go ahead. We have seen.
So I will start with some basic ideas.
Volume.
So this is a very popular advertisement of a multinational health drink. One particular health drink makes kids taller, stronger, sharper. Now the question is this: how can this particular company arrives at such a decision that it will make kids taller, stronger, sharper? Let us forget about being stronger and sharper. Let us think of taller only. That means a health drink claims that it will make the kids taller. Now, how we will assume that the company is saying whatever they are claiming truthfully. They have conducted an experiment, and as an outcome of the experiment, they are claiming that the kids will become taller. But how the experiment is to be designed? Let us take two kids. One is given that particular health drink, and the other one an ordinary health drink. Now, it may be seen that after some time, say 6 months or 1 year, the kid who has received Horlicks has become tall. But will that imply the efficacy of this particular health drink? Obviously not, because the kid who was given that particular health drink may have better initial conditions in terms of better birth weight, better nourishment, etc., etc. So, how the experiment should be performed? Obviously, we have to replicate the experiment. That means we have to take a group of children who will be given that particular health drink, and another group of children will be given an ordinary health drink. And after some time, obviously, we will see that thing. But again, the group who has got that particular health drink may have all of those kids may have better initial conditions. So obviously, the health drink will show better result. At that point of time, so what should we do? Obviously, then the next question comes in is the question of randomization. That means we cannot select some kids with better initial conditions and give them that particular health drink. This cannot be done. So we have to randomize the whole thing. That means we have to randomly allocate this particular health drink to a number of kids. And then we can
burada proqramda desən biz
and
necə
obviously when
vaxtlarda
we can
səhv
see,
eləmişik
we
ya
can
da
see
kimsə
that
az danışdı, bilmirəm.
after say 1 year, we see
Siz
the
zəhmət olmasa 2-20
growth in
dəqiqə,
their
2-20
height.
dəqiqə işləmiş çıxış elə bilərsiniz.
For both the groups.
Mən deyəcəm bunu.
Now, is it necessary that
2-20
all
15
children
dəqiqədən
of the
sonra
first
qurtarsın,
group
bundan
who
sonra
have
siz
got that
olmaz.
particular health drink will show better growth in terms of height than all the children in the second group? No. Then what should we take? We can take the average. That means implicitly we are assuming that a data set can be represented by a single value. So the question will be how to find out that representative value. I'll come back to this point later. Let me take one more example. Just read the last line. Removes 99.9% germs. Let us forget about 10 seconds. Removes 99.9% germs. How to calculate this? Has this hand wash been applied to each and everybody under the sun? Obviously not. So that means we must have taken a sample. So in the sample that we have taken, did their hands were all dirty in the same amount or not? And when we had taken the sample, how did we take? The clean hands or the dirty hands or a mixture? Then also, you see, the randomization, the uncertainty of selection of sample takes a very important part here. That means we have to select the samples randomly from the whole population. And here, when we are claiming the last sentence, when the company is claiming the last sentence, then they are implicitly saying that from a set of sample observations, one can infer or predict or guess about some characteristics of a whole population. Okay?
Yeah.
This is a funny one.
Yes. Oldu. Çox sağ ol.
Two persons are going when it's lightning.
Qutarandan sonra deyərəm.
And one is saying we should get inside, and another is saying it's okay. Lightning only kills about 45 Americans a year. So the chances of dying are only 1 in 7,000,007. So it's a very less chance. Let's go on. So what does this chance means? Does probability, a very low probability, mean that the event cannot occur? Obviously not. The event can occur. And the event can occur very often. Maybe for a short period of time. And for a very long period of time, the event may not occur at all. So when we understand
Alo, Səmir, mən bağışlayın, yenə narahat edirəm sizi. Hə. Bir dəqiqə, indi onu şeydən göndərərəm, eventdən göndərərəm. İkisindən də qoşulmaq olur, mən həmişə ikisindən də qoşul. Я поняла. Bildim. Amma deyəcəkdim ki, harda? Kompüterdə yoxdur. İndi mən eventdə bir də sizi əlavə eləyərəm, bir də yoxlayaram. Sadəcə deyəcəyim ki, indi Ehsan mənim danışacaq, siz elə 3-10-da danışarsınız. Hə. Yaxşı. İndi onu düzəldirəm, sizə gəlsin. WhatsApp-a mümkünsə baxın, mən oraya yazaram. Sounds. Dr. Chandra, I'm sorry, but your microphone is muted.
Yes, something happened and then
Okay.
I thought.
No problem.
Now can you hear me?
Yes, we can hear.
Okay. I also lost the controls also. Anyway, now it's fine.
Yes,
Thank you.
I can hear you.
Okay.
Yes, sir.
So the first concept is central tendency. As I mentioned earlier, that a set of observations can be represented through a single value. So that's why we can say whenever we collect some raw data, there is a general tendency of the observations to get clustered around some central value. This tendency of the observations to get clustered around some central value is known as central tendency. And obviously, the central values will also be called a measure of central tendency. The most important thing is this: the measure of central tendency generally provides us with a representative value of a given set of observations. So that means we can find a representative value for a given set of observations. That is important. Obviously, we all know what is arithmetic mean. I will not go into the calculations and all these things. I'll just request you to look at the observations. So we have a set of observations, 7 or 8 observations, and the arithmetic mean is coming out to be 88.11. Now let us look at the observations more closely. Do we really think 88.11 is a representative value of the given set of observations? You see, all but one observations are much lesser than 88.11. All but one observations are much lesser than 88.11. So 88.11 cannot be a representative value for this set of observations. So, what is the problem? So, this was the question that I tried to answer, and we will answer just in a minute. We go to the next measure of central tendency, which is called median. It is the middlemost value of a set of observations. So we first arrange the observations in an increasing order. We could have arranged in a decreasing order as well. And we find that the median is 23. Now you see, 23 is a much better representative value than 88.11. So in this situation, median is a more appropriate measure of central tendency than arithmetic mean. But we are all fascinated about calculating arithmetic mean. So before computing arithmetic mean, we need to know the nature of the data. So what we have to look into? When there are a number of observations with 1 or 2 observations that are widely different from the others, in our set of observations, 609 was widely different from the rest of the observations, then those different observations are called, we know, outliers. And in the presence of outliers, median is a better measure of central tendency than arithmetic mean. However, one may calculate the arithmetic mean after discarding the outliers. In the present situation, the arithmetic mean also becomes 23 if we discard or omit the outlier 609. Here 609 is an outlier. Makes sense. So either we can go on calculating median, or we can calculate arithmetic mean, but there is a word of caution. We have to discard the outlier and then calculate the arithmetic mean. Now, when we have a large set of observations, very large set of observations, now we are, as we know that we are living in an era of data, big volumes of data. So, there is a tool called box plot through which we can identify the outliers. It is available in any common statistical software. I prefer using R in such situations because R is a free software as well as R has a lot of potentials. The third one is mode. Here the data set relates to the sizes of shoes sold at an outlet. If I calculate the arithmetic mean, I find 5.65 and the median comes out to be 5.5. So do we really think that 5.65 or 5.5 can be a representative value of this data set that represent the sizes of shoes? Obviously not. It should be a whole number. Here the mode, if we calculate the mode, which is the most fashionable value or the value having the maximum frequency, comes out to be 6. And definitely here 6 is a representative value. I will not go into the other characteristics of data set or a frequency distribution. As I mentioned, central tendency, dispersion, skewness, and kurtosis. The most common measure of dispersion is central tendency. Obviously, here we are all learned, so I'm not going into the formula and all these things. Central tendency. The most common measure is standard deviation for dispersion. For skewness, it is gamma 1, the coefficient of skewness, and for kurtosis, it is gamma 2, the coefficient of kurtosis. So for those situations also, if we have outliers in a given data set, first we will omit the outliers, we'll discard the outliers, and then we'll calculate these coefficients. So my next part is testing of hypothesis. So first, let me just go through some concepts. In any statistical inquiry, the ultimate interest of the inquirer is in some numerical characteristics of the population, like population mean, population variance, etc., etc. We call these characteristics of the population as parameters. And obviously, as we've seen earlier in the slide of that hand wash, that 99.9, obviously that cannot be that has not been obtained by investigating each and every member in the population. Obviously not. So a sample was taken. So a population can be guessed or can be inferred by a sample. So to satisfy our inquiry, the inquirer draws a random sample from the population and makes use of some sample characteristics, like sample mean, sample variance, etc. These sample characteristics are known as statistics. Now, in particular, theory of inference has got many facets, but I will talk about only one such facet, that is testing of hypothesis. Here, the inquirer starts with some tentative idea regarding the unknown population, and on the basis of the sample observations, he tries to judge whether this idea is tenable or not. We have a tentative idea that a particular hand wash kills 99.9% germs, but as customers, should we accept this fact blindly? Obviously not. We have to test that. So this tentative idea is called a hypothesis, and the way we judge its validity or test its validity is called a test of the hypothesis. Null and alternative hypothesis, the hypothesis that we know all. The hypothesis which is set up and we test the validity of which against possible alternatives is called a null hypothesis, and these alternatives which contradicts the null hypothesis is called an alternative hypothesis. So if my null hypothesis may be a particular hand wash kills 99.9% germs, so my alternative will maybe the hand wash kills less than 99.9% germs, something like that. Now, when we test for a hypothesis, we may commit two types of error, type 1 error and type 2 error. The error of rejecting a null hypothesis when it is actually true is called type 1 error. And the error of accepting a null hypothesis when it is actually false is called type 2 error. it may be that when we are testing the hypothesis that it is 99.9 and less than 99.9, it is possible that the hand wash is actually effective. But for the persons that we have chosen, they haven't washed their hands through that hand wash properly.
Alo.
Properly. So,
Bəli. Tamam.
when after washing, when we see the germ content in their hands, it may not have been reduced by 99.9%. So even if the hand wash is effective, the sample result may show that the hand wash is not effective. That means there is a chance of rejecting a null hypothesis when it is actually true. Similarly, it's possible that the hand wash is not effective, is not actually not effective. But somehow the persons that whom we chose randomly, they may have washed their hands earlier and then they washed with this particular hand wash, and then the residual germ content may be very low. So that it is possible there is a risk of accepting a null hypothesis when it is actually false. But both of these are errors. We call them type 1 error and type 2 error respectively. So it's a table which shows us the different types of decisions that might occur, or different situations that might occur in a testing of hypothesis problem. Obviously, when H0 is true and we accept it, we are taking correct decision. When H0 is false and we are rejecting it, we are committing type 1 error. H0 is false and we are accepting H0. That means we are committing type 2 error. And when we are rejecting H0 when H0 is false, it's a correct decision. But one thing we have to keep in mind that when we test for a hypothesis, we will never know whether we have committed an error or we have taken a correct decision. What we can find out are the probabilities of the errors as well as the probabilities of taking correct decisions.
Okay.
Now we often call it 5% test, 1% test, something like that. But what do we really mean by that? Do we blindly follow what is 5% or 1%? Or we should give some thought before applying these things. Obviously, as we mentioned, that a testing of hypothesis may lead to error, may lead to erroneous decision. So it would have been ideal if it could minimize the probabilities of both the kinds of error. However, in tests with fixed sample size, I'll explain this term, it can be shown theoretically that minimization of one kind of error results in the maximization of the other kind of error. That means, in other words, we cannot minimize both the types of errors or probabilities of both the types of errors simultaneously. And when we consider tests, in other words, normally we consider fixed sample size test. That means right at the outset, we decide what will be our sample size. And we can take two types of decisions out of the sample observations. Either we can accept H0 or we can reject H0. But there is another type of testing where one can take three types of decisions: accept H0, reject H0, and the third type of decision is defer your decision and consider some more sample observations. That means what decision to be taken, we may consider some more sample observations. But normally in parametric setup, we consider, even in non-parametric setup, we consider fixed sample size tests. So what I was saying, that we cannot minimize the probabilities of both the kinds of errors simultaneously. So what we do, we put an upper bound to the probability of type 1 error and then try to minimize the probability of type 2 error as far as possible. That means we do not allow the probability of type 1 error to go beyond a certain level, and under this restriction, we try to minimize the probability of type 2 error as far as possible. This upper bound to the probability of type 1 error is known as the level of significance of the test. And this level may be 0.05 or 0.01. And accordingly, we will have 5% test or 1% test. Now, the question is this: do we have only 1% or 5% test? It cannot be anything else. Yes, it can be anything between 0 and 1. If we think that type 1 error will be very fatal, then obviously we'll go even less than 1%, we'll fix the upper bound to the probability even less than 0.01. And if we see, if we say yes, somehow it can be relaxed to some extent, then we obviously will go for a higher value of the level of significance. Now, mind you, as I said in the second point, that minimization of one kind of error results in the maximization of the other kind of error. That is, if you try to reduce probability of type 1 error, then it will result in an increment in the probability of type 2 error. So, if type 2 error is fatal, then we have to make a balance between the level of significance, that is the probability of the upper bound to the probability of type 1 error, and type 2 error, probability of type 2 error. So these things are to be considered. We cannot blindly go for a 1% test or a 5% test. Now this is p-value. In every software we'll find, every statistical software will find that they're giving p-values. They're, as in output, they're giving p-values. So what are these p-values? And on the basis of the p-values, we have to take the decision whether to accept or reject a null hypothesis. So suppose we are going to test H0. H0 is the null hypothesis. Theta equals to some theta naught. Theta is a parameter and theta naught is some prescribed value of theta against H1, 1, theta greater than theta naught, or H12 theta less than theta naught, or H13 theta not equal to theta naught. Now obviously we'll test one null hypothesis against one alternative hypothesis. Okay, but here I'm discussing all the three alternative hypotheses simultaneously, but for a given problem, we will consider only one null hypothesis and only one alternative hypothesis. Suppose T be the test statistic. That means the sample characteristic, and small t its value 5, 10, 29.35, etc. Then p-value is defined in this fashion. If the alternative is H11, then probability capital T greater than small t. If the alternative is H12, then probability capital T less than small t. And when the alternative is H13, that is twice minimum of these two probabilities. Okay. Now we reject the null hypothesis if p is less than alpha, where alpha is the level of significance. Now you see, normally we used to see the tables and all these things for level of significance. We see that biometric table for T distribution, F distribution, chi-square distribution, standard normal distribution, etc., etc. But we do not really rely on a table now, because this alpha, the level of significance, may be anything. It is not necessarily 0.05 or 0.01. I can take 0.13 as the level of significance, and obviously what the level of significance will be depends on the study that I am carrying out. It will not depend on any statistical theory, but it will depend on the actual study what I am carrying out. So if it is a say drug testing on drugs, some medicines, then obviously type 2 error will be very fatal. That is, the drug is not effective, but from our sample data we are saying that the drug is effective. That will be very fatal. So that means we can relax type 1 error to some extent so that type 2 error can be minimized. So these sort of adjustments can be done using p-value. Now, for the sake of an example, I'm taking this. We all know the procedure of this testing. One sample t-test. We consider a normal population with mean mu and variance sigma square, where both the parameters, that is mu and sigma square, are unknown. And my problem is to test mu equals to mu naught against mu not equal to mu naught. Mu naught is a specified value of mu. Okay. So mu is the population mean, sigma square is the population variance, and we are testing whether population mean is equal to some specified value. Population mean is equal to say 0.95. Okay. Something like that. Mean is equal to 209. Mu naught, so mu naught is a specified value. So how will you, or the average amount of germ removal will be 99.9, something like that. So obviously what we'll do, we'll take a sample. So, and we'll take the sample randomly, as I mentioned earlier. So x1, x2, xn is a random sample drawn from the population. And here we assume that the underlying population is normal. In most of the situations, what we do, we go for a t-test, but we do not test whether the underlying population is normal or not. Unless the population is a normal population, that means the population distribution is a normal distribution, unless that condition is satisfied, we cannot apply t-test. We cannot apply t-test. So, what we do normally is this: we calculate the sample mean, the sample variance, we compute the test statistic, and we see, if I see that the test statistic exceeds the tabulated value, then we reject the null hypothesis. If the absolute value of the test statistic, because the alternative was mu is not equal to mu naught, we had a two-sided alternative. So if that is greater than that, the tabulated value, we reject the null hypothesis. So that is what we do. But what they say, this is a sample, and the things are given, the values are given, and we have to test at 5% level of significance whether the true melting point of the compound is 165 degrees centigrade, and the tabulated value is given as 2.201. So here mu naught is 165 degrees centigrade. Now, as I mentioned, the first step is to see whether the sample has really been drawn from a normal population. Unless that is met, unless the population is normal, we cannot apply t-test. So we have to test for normality. We have to first go for the test for normality. Before computing all these x bar, s square, sample mean, sample variance, etc., etc., we have to go for the test of normality. Now, there are a number of tests to verify whether a sample is really drawn from a normal population. One of these tests is Shapiro-Wilks test or Kolmogorov-Smirnov test. These tests can be carried out through softwares. Now, what does this test say? Shapiro-Wilks test or Kolmogorov-Smirnov test, those are same tests, just there's a little bit of difference in the test statistics, just a shift of origin. So here the null hypothesis is that the population is normally distributed. Thus, on one hand, if the p-value is less than the chosen alpha level, that is the level of significance, then the null hypothesis is rejected, and there is evidence that the data tested are not normally distributed. So if we reject the null hypothesis, that means the population is not normally distributed. That means the data set, the whole data set, they do not have a normal distribution. On the other hand, if p-value is greater, then the null hypothesis that the data came from a normal distributed population cannot be rejected. That means we accept the fact that the data comes from a normal population. So this Shapiro-Wilks test has to be carried out first, and this is a typical output of the Shapiro-Wilks test. And you can see the mean, standard deviation, number of observations, the RT, the rejection value, and as well as the p-value is given to us. The most important thing is this p-value. So this p-value, if we take alpha, the level of significance at 0.05, then we can say that for this plot, the data set can be regarded to be drawn from a normal population. So the first step will be to carry out this test for normality, maybe a Shapiro-Wilks test. And if the normality assumption is valid, that means if Shapiro-Wilks test is accepted, then we can go for a t-test, one sample t-test. But if this is violated, we should apply some non-parametric test. So, for a given data set, we have to check whether normality assumption is really valid. If it is valid, then we go for parametric tests. Otherwise, we go for non-parametric tests. So this has to be kept in mind. We cannot blindly go for a parametric test because literature says that parametric tests are more robust than non-parametric tests. But if the basic assumption of the parametric tests are violated, then obviously the parametric tests will lead us to erroneous results and erroneous conclusion. So we have to be cautious about those things. Now I come to correlation analysis. I'm just picking out some areas. Obviously, it's not possible to cover all possible such areas where controversies may arise, but I'll pick up 4 such areas where we have to be cautious before go for computation and presenting the result. We consider the following data set. We know correlation coefficient that concerns bivariate data. So we have data on 2 variables X and Y, say heights and weights of a number of individuals, blood pressure and blood sugar level of a number of patients, so on and so forth. So the data set, just give a close look to the data set, -3, 9, -2, 4 and all like this. And if we calculate Pearson's correlation coefficient, it will come out to be 0. Now, the question is this 0 value will lead us to believe that there is no relation between the 2 variables X and Y? Now, if the value of the correlation coefficient turns out to be 0, obviously we will not necessarily mean that there does not exist any kind of relationship between the 2 variables, or that they are independent. In such situations, we can only say that there does not exist any linear relationship. So we are so crazy about calculating correlation coefficient, and if we find a very low value of correlation coefficient, then we say that the 2 variables are not related. But this is not true. Let us see the real picture. If I plot X versus Y, in the horizontal axis I have plotted the values of X, and along the vertical axis the values of Y. Can you see? It's a very nice quadratic relationship. There is an accurate quadratic relationship between the 2 variables given by y is equal to x squared, a perfect parabola. So there is a very strong relationship between the 2 variables x and y, but this relationship is a quadratic relationship. But correlation coefficient is 0. That means when we see that there is no linear relationship, we have to go for non-linear relationships. We have to investigate whether there are non-relation relationships as well or not. And finally, I'll arrive at regression analysis. Let us consider the following regression equation. I've taken a multiple regression equation, something like that. There are 4 explanatory variables, x1, x2, x3, and x4, and y the response variable. The R square value comes out to be 76.34%. What we can say about the fit? Is it a good fit, or a bad fit, or a moderate fit? Now see, R square value is 76.34%. First of all, R square, which is also called the coefficient of determination, it gives us the proportion of variation that is explained by the regression, or proportion of the total variation in the data set that is explained by the regression equation. That is R square. So that means here we can say that 76.34% of the total variation has been explained by the regression equation of y on x1, x2, x3, and x4. Now, whether this is good or bad or moderate, how can we decide that? Before making any such comment, we should verify the usual assumptions. What are the usual assumptions? Homoscedasticity of errors, normality of errors. Now, homoscedasticity of errors is a very important assumption. When we carry out regression analysis, homoscedasticity is a very important assumption. And also, the errors are to be normally distributed. Otherwise, those when we get a regression output in any software, we see t value, then p value. These p values are computed on the basis of normal population. So if normality of errors are violated, then those p values will not have any significance. Those will be completely wrong interpretation of the data, unless the errors are normally distributed, and unless the errors are homoscedastic, that means equally variable. Skedasticity, we all know, means variability. So homoscedasticity means equal variability. Unless the variability of the errors is homogeneous, then this R square value doesn't have any significance. Actually, this regression equation that I shown in the previous slide does not have any significance. Why do you carry out a regression analysis? Because we'll put the values of x1, x2, x3, x4, and we'll predict the value of y. That prediction will be completely wrong if the assumption of homoscedasticity of error is violated. So before going on carrying regression analysis, what we have to do? We have to check whether the errors are homoscedastic. There are graphical methods, there are objective type of tests. So graphical detection of heteroscedasticity is generally corroborated by suitable tests. So graphical method is this: we give a scatter plot. Now, if a scatter plot of fitted versus residuals shows systematic patterns, because we know covariance between, in regression analysis, covariance between fitted values and residuals is 0, theoretically. But if they show a systematic pattern, obviously there is something wrong. We will suspect heteroscedasticity. On the other hand, a complete random pattern will suggest homoscedasticity. But the question is this: from the graph, it is not always possible to know, or rather, it's not always possible to decide whether homoscedasticity is present or not. That's why we have to go for tests. May I know how much time do I left with?
10 minutes. 10 minutes.
Fine. Thank you so much. Thank you so much. So the tests, one of the tests is Glazier's test. We consider a multivariate model, and you see, if the errors are homoscedastic, then variance of UI will be equal to sigma square, not sigma I square. Variance of UI would have been equal to sigma square. So all variances of all errors would have been equal. But if they're different, then the problem is there. Now we consider a model with sigma I. Obviously, this type of a model suggested by Glazier. This is true for alpha is equal to this, 1, 2, p, etc. Now the problem is to test delta 1 equals to 0. Now see, if delta 1, look at this thing. Obviously, if we multiply it by delta 1 here, if that is 0, that means the errors will be homoscedastic. So we have this. In this sigma I are in general unknown, so we take the absolute values of the errors, observed errors, or the residuals. So this is the model that we take. Now if delta 1 is 0, you can see that this will be homoscedastic. Now if H naught is accepted, the disturbance terms may be assumed to be homoscedastic. That is the point. Now to detect the form of heteroscedasticity, if H naught is rejected, then there will be heteroscedasticity. So we have to detect the form. Glazier proposed 4 standard values, -1, -half, and 1. And accordingly, our model will become this. If we put delta 2 star equals to -1, then the first model will get, if I put -half, then the second model, and so on. Now you see, just look the first model. If this happens, then EI is mod EI is the estimate of sigma I. So that will be proportional to 1 by x alpha I. But then that means sigma I square will be proportional to 1 by x alpha I square, and so on. So that means we'll be, if the model is homoscedastic, no problem. But if it is heteroscedastic, then we obviously have to perform Glazier's test, and we have to identify the nature of heteroscedasticity, and we'll perform a t-test for each variable. And if all t-tests are accepted, we may proceed with the original model. That means we need not go for anything else. Otherwise, this is very important. If any one of the t-tests, the 4 t-tests we'll consider, if one of the t-tests, as I have shown in the previous slide, 4 such tests will be performed. And if any one of them are rejected, then we have to take some remedial action. That means we cannot carry out ordinary least square technique, but we have to carry out generalized least square technique. So that means when we cannot blindly work with the output, with a regression output, we have to check whether the data are homoscedastic or not. If they are homoscedastic, fine, but we have to check for that. We have to go for these Glazier's tests. There are other tests as well, and also, but if they are heteroscedastic, then we have to go for some other technique, that is generalized least square technique. Now we consider the regression output once again. The p-values for the coefficients have been found to be 0.791, 0.504, 0.001, and 0.599 respectively. So you see, The overall fit of the regression is good, but 3 out of 4 explanatory variables are insignificant. Look at the p-values. They are all greater than 0.05 or even greater than 0.01. So that means x1, x2, and x4 are insignificant. So we can simply drop them. We can simply drop these variables. So where the shoe pinches. The problem is the problem of the data set. That means whether they are homoscedastic or not, whether they are normally distributed or not, all are to be judged from the data set that we have in the hand. If we calculate the partial correlations between the explanatory variables, we shall find that at least 3 of the variables will show high partial correlations. That means they are interdependent. In other words, the response variables may be found to be multi-collinear. We then have to take a suitable remedial measure. That means we have to test whether the explanatory variables are interrelated. That is, whether there is a problem of multicollinearity or not. So we have to check for that also. I'll not go into the details of multicollinearity today, but we have to go into that also, and then we have to take remedial measures. So in a nutshell, I'd like to say that before making use of any statistical measure and going for computation, we have to check whether the underlying assumptions are being satisfied. Otherwise, we shall keep ourselves lying in the vicious circle of lie, damn lie, and statistics. Thank you so much. If anybody has any kind of question, I'll be very happy to answer.
Any question? Thank you, Dr. Oyen Chandra, for delivering such an informative lecture in a lucid way. It is really a fruitful lecture session. And thank you once again for giving your time despite your busy schedule. We are really thankful to you, sir, for your positive attitude towards the workshop. Thank you once again.
Thank you so much.
Thank you, Dr. Chandra, for the interesting presentation and for the attending to our workshop. Now I want to apologize to one of our invited speakers, the Professor Elviz, have the problem with the connection. Now his speech will be presented by the invited professor of Azerbaijan State Oil and Industry University, Ehsan Musavi. It will be about challenge of influence dynamic and interactive events on research discovery functionality in outside of distributed exascale systems. Please, Professor Musavi, if you are able.
Thank you very much. I tried to share my screen on behalf of the professor. Nigar, do you see my presentation in your view?
Yes, it's okay.
Yes, okay, that's right. Thank you for your attention and thanks for giving me this time that I try to represent the Professor Aliyev presentation about the challenge of influence, dynamic and interactive events on the resource discovery functionality outside of the distributed exascale system. As you know, we changed the era from the petascale to the exascale systems. We have 2 different definitions for the exascale systems. One is the 10 power 80 flops. It means from the view of the hardware and the design and develop the hardware for the achieve or obtain the exascale systems. But main issue occurred in the software. We in the traditional high performance computing system, we are using the high performance computing system for the reducing the time, only reducing time. we obtain the nature rules in the scientific area, for example, in the chemical, in the physical, in the mechanical area, and we programize the rules to run on the high-performance computing system in the low response time. But when we change the era and there comes exascale computing era, we are using the supercomputer for understanding, for discovering, for cognitive the rules of the nature. For example, you can see some application in this picture. For example, high energy physics, data analytics in earth science, molecular dynamics, neuroscience, and imaging is a example of these programs. In these programs, we are using some basic rules.
Şeyine bak.
Ne oluyor? Dayandı. Dayandı, ne oldu?
Düşler mi?
Excuse me. I think I lost my picture. Yes. Okay.
Yeah, now it's okay.
Now okay. For example, these chains have many issues. For example, the concept of the dynamic and interactive events has been created and designed for the HPC systems. Concept of the D&I first time by the Professor Grandinetti and me and some other researcher in the high performance computing system is introduced. D&I means an event occurred in the system that we don't have any response structure for solving and managing these events. For example, in the science, when in the running the science programs, when when occurred a dynamic fork, it means that a variable in the system discovered by HPC systems that we don't have any response structure for manage and control it. Or another type of the D&I is the communication D&I. It means that the two persons communicate together, that we don't have any response structure for control and manage it. It means in the real world that the two variables about our subject connected together, that this connection is not discovered before. And the type of the tree of D&I is the interactive. It means that one process communicates with another process out of the systems. Therefore, we don't have any response structure for managing this event. This type of the events may have many challenges for the traditional high-performance computing systems. If we see and redefine the concept of the HPC in the exascale computing system, we can find the three main basic. One, using the understanding the law of the nature. Two, the HPC from the optional part of the discovering or from the optional part of in research about the basic rules like the gravity becomes to the necessary part of the discovery. And the third, time limitation. Time is the very important concept in the HPC. We try to reduce the time and answer the request in the low response time. But in the distributed exascale computing system, we have another challenge about the time. That is the time name is the dynamic and interactive times. What we do, we have a truth approach for the solving this problem. One, redesign HPC manager for the supporting distributed exascale computing system. Two, improve or empowerment our HPC manager to support the distributed exascale computing system. Approach one is not acceptable for us because, as you know, HPC programs is a very traditional application. For example, MM5 is a 1960 developed, and until now, many countries use it. Or HRM, Nike, Charm++, is a type of the application that designed is many years ago, and now we are using them. And they are based on the Fortran application, and we don't interested to change them. For the solving these problems, we must have a good image about four type of the dynamic and interactive events: dynamic and interactive fork, dynamic and interactive communication, and dynamic and interactive interactive. As you know, HPC manager using this architecture, it is a very simple architecture, not with the many components. We have in the underlayer interprocess communication, fundamental and the axial element is the load balancing, migration, and the resource discovery. As you know, resource discovery is not used in the cluster computing, and resource discovery is a part of the grid and the peer-to-peer computing systems. What we do for the as you know, the resource discovery is a very important part in the grid and peer-to-peer system, because in the system's accorded request, that system cannot support it, and the system cannot answer this request. Therefore, resource discovery in the traditional HPC system activated, and based on one of the approach, like the structural or unstructured approach, finding the resource and give the permission and allocate the resource to the process that requested. Therefore, if we delete the resource discovery concepts, we cannot use the distributed systems for the HPC system. For example, if we remove the distributed resource discovery concept from this architecture, therefore this architecture only used on the supercomputer and the spatial clusters dedicated and only using in the narrow works or the running the narrow works. Therefore, resource discovery, this part of the HPC manager for the finding resource out of the system. Out of the system is very difficult. Out of the systems, the sound is very difficult, because when we discussion about the out of the systems, we discussion about the area that our system's rules is not acceptable and is not running. Therefore, out of the system have many spatial requirements. Resource discovery used in some system using the resource attribute set, RAS. Resource discovery for using the expanding of our systems. As you know, in a distributed systems, we are one of the main attributes of the distributed systems. We have three basic attributes in the distributed systems: scalability, transparency, and openness. If you see scalability and openness, describe about how to expand our system, how to extend our system. In the traditional HPC systems, when the process want to access resource, that resource is not is not available in the systems, the state of the responser is a constant, and the requirement of the requester process is not changed during the resource discovery activation, and the requests don't change. For example, if process say, okay, I want to access the file, process during the execution of the resource discovery don't change the request, don't change the requirement, and don't send another request about the, for example, memory. Response after the if the process finded by the resource discovery that can response to our request, the response is not changed. Therefore, based on this, we can define the resource discovery functional state based on a resource attribute, resource state, and remain. As you know, we can represent the resource discovery finding approach in the this picture. As you see, first resource discovery is try to finding, second is try to add remove resource, third is the permission, and finally allocate the resource to process. One. Allocate the resource to permissions. We try to obtain and reach the resource discovery functionality in outside of the system. Pay attention to this point that we have a two parts. Resource discovery have a functionality function in the inside of the system, and resource discovery have a functionality function for the out of the systems. Therefore, we have two different resource discovery function. In this presentation and this project, we are trying to defining the resource discovery function in the out of the system. As you see, if their machine alpha can answer the request, we can write this function for the machine alpha. Alpha establish has mapping a request to the answer. Request is based on a for function defined, and the answer based on a three variable defined. And the mapping do by this matrix. This matrix is the mapping the request to the answer. Request defined based on a time, location, system, and condition. Means that we have a request have a time limitation, a location limitation, system limitation, and communication limitation. This type of each of these variables create a space. For example, time limitation space, location limitation space, system limitation space, and the communication limitation space. Therefore, request become a space that's defined by this for space. And then, like the answer have a state of the resource attributes. It is a very complex space resource attribute, and the remaining or not remaining. Remaining and the not remaining on the system. It is the integer variable. Therefore, answer becomes a space based on a two space and the one integer concept. Mapping based on a for limitation or for condition describe the to answer the request, time, operation, how which type of the operation can define it on the on a resource that exists in the alpha machine, and the system condition. This function, when the request answered by the machine alpha, is the constant and don't change and don't change the part of this functionality. But in the distributed exascale, D and I, when D and I occurred, D and I may be occurred in our systems, or in our out of the systems. D and I may be influenced on a resource discovery in a three location. One, resource D and I occurred on the requester process and the request of the process and the requirement of the process like this changed. During the resource discovery, D and I occurred and D and I occurred this D and I changed the resource discovery operation. And finally, in the outside of the system, D and I occurred, and the responser status is the change. Pay attention to this point that maybe change the reason of the resource discovery. For example, the requester process change and the requirement of the process is the answered in the systems. Traditional systems in the resource discovery in the traditional systems only for finding the allocation, only for finding and allocation the resource to the process. But in the distributed exascale computing systems, for the solving the D and I, we Ian Foster and Lucio Grandinetti describe the 2 approach. One approach is the using the expand and scalable our systems to solve the problem, and second approach is the using the change functionality. Change functionality approach is very difficult because we must change the resource attributes, change the resource behavior, change the resource functionality, and in the expanding system, resource discovery goes create the new concept that name is the global activity, and based on a global activity finds a resource can based on this we can manage this D and I. Therefore, resource discovery in the distributed exascale computing systems used for the creating response structure to manage this dynamic and dynamic and interactive events. Therefore, in distributed exascale computing system, resource discovery used for finding and allocation, matching. What means matching? We define it. Matching and the create response structure. Find and allocations becomes from the traditional HPC systems, but matching concept it's defined in the distributed exascale systems. In matching, we say that if resource discovery cannot find a responser that equal of our request, resource discovery can find a resource that very similar to our resource. It is the similarity concept based on a similarity in the mathematics. It can define it. In the resource discovery, is a state is the change in the traditional based on traditional systems. In the traditional systems, the resource discovery only in the ready state, finding a state, and accepting a state. But in the distributed exascale, we have many new state. One, reserved global resource. 2, running global request. 3, running local request. And 4 is the multi-global request. When resource discovery is start working in the ready states, and only can answer the local request, or becomes a member of the global activity and running the global request. In distributed exascale systems, we introduce a new concept that is a multi-global request. In a multi-global request, distributed machines becomes a member many global activity that cross it on the machines. Therefore, resource attribute, resource state, and the remaining, as you remember, is defined for the resource discovery functionality in the answer matrix. In the answer, maybe influenced on the D and I. Therefore, we need to extend the matrix. What means the extended matrix? Extended matrix means that we must to change this matrix. This matrix from the multiple dimension to three multiple three dimension, and becomes to this state, and redesign the resource attribute state based on a time. As you see in this time series, resource limitation, local system limitation, global activity limitation, time usage limitation, permission allocation, and similarity function. We try to extend the resource discovery for the managing the D and I in out of the systems that our rules is not applied and maybe accorded D and I, and we extended the function of the our resource discovery to compatibility with the old and traditional application. For example, now, as you know, in the COVID, we are using the bonic systems for the simulating the bonic and understanding the functionality and the behavior of this virus. If we this virus is a good example of the dynamic and interactive and active application. We don't have any information about the we have a little information about the coronavirus. Therefore, we try to understand and discover the functionality and the behavior of this virus. Therefore, if we want to be using the bonic, that his name is the traditional high-performance computing system, we need to extend resource discovery to support the D and I challenge. Thank you very much for your attention, and please accept my applause for the presentation. Nika?
Thank you, Professor Musavi. Thank you for the interesting presentation about the exascale computer systems.
Thank you very much.
And if participants had questions, you can ask, or you can type on the chat. And also tomorrow we will also have an opportunity to listen to the Professor Musavi about our HPC center of our university, and also the another challenge in the exascale computing.
Thank you very much. Thank you. If you have any questions, I'm in your service. Thank you.
Thank you very much. So, Tapalina, I think that now we can move to the paper presentation session. Can we? Tapalina? Okay. Now let's start our paper presentation session, and in this session we will have five presentation by the academic members of the St. Xavier's College, and also by the Azerbaijan State Oil and Industry University. Sorry. Okay, now I think that we can move to the paper presentation session, and I think that here we have the thank you for Rakesh Kumar. Thank you for your comment. Now I want to introduce, I want to start the paper presentation session where we'll have 5 presentations by the academic staff of the Azerbaijan State Oil and Industry University, and also by the academic staff of the St. Xavier's College, and also by the member of our partner of our Azerbaijan State and Oil and Industry University HPC Center, the partner from Azercosmos Space Agency. Now I think that we can start, and I want to ask the Associate Professor of the Azerbaijan State Oil and Industry University, Samir Kuliyev, to present his topic.
Thank you very much, Nigar. Do you hear me?
Yes, we can hear you.
Hello, do you hear me?
Yeah, I can hear you.
Yeah, okay. Hello, everybody. My name is. Let's show the presentation first. All right. My name is Samir Guliyev. I'm an associate professor at the General and Applied Mathematics Department of the Azerbaijan State Oil and Industrial University. And today I would like to make a presentation. I would like to talk about the applied, one of the applied engineering problems that I believe can be solved efficiently using a high-performance computing system. So that this is the title of presentation: synthesis of zonal control of lumped sources for the heat conduction process. So we consider the problem of synthesis of control of lumped sources for an object with distributed parameters on the basis of discrete observation of the phase state at certain points of the object. We propose an approach in which the whole phase space at the observed points is divided preliminarily in some way into given subsets, which we will later call zones. The synthesized controls are taken from the class of piecewise constant functions, and their current values are determined by a subset of the phase space containing the population of current states of the object at the observed points, at which controls assume to take on, for example, constant values. Let's say constant values. Such synthesized controls are called zonal. We give a numerical technique for obtaining optimal values of zonal controls using efficient first-order optimization methods. That is, methods based on gradient-based methods. To this purpose, we derive formulas for the gradient of the objective functional in the space of zonal controls. So it is known that one of the important areas in the modern theory of automatic control is the theory of control of systems with distributed parameters. That is, these are systems described by partial differential equations. The problems of synthesis of distributed control systems are in most cases much more complex than lumped systems. Lumped systems are systems described by ordinary differential equations due to the characteristics of distributed objects. The distributed control objects include many chemical, technological, radiation, hydrodynamic processes, heat conduction and diffusion processes, and processes associated with the movement of elastic structures, etc. The absence of a formalized methodological approach for solving problems of control for distributed parameters poses certain problems for researchers that require the use of non-standard research methods and decision-making in each specific case. Modern technical means of measuring and computing technology, especially computing technology, which make it possible to carry out a large volume of measuring and computational work in real time, have played a key role in the development of feedback control systems and their widespread practical implementation. We consider the problem of synthesizing control of an object with distributed parameters and special classes of control actions. For the synthesized controls, the concept of zoning is introduced, which means the constancy of the values of the synthesized control parameters in each of the predefined subsets. These so-called zones are obtained by means of partitioning the entire set of possible states of the object or the time interval of the functioning of the process into separate chunks. The values of the control actions are also determined by the type of feedback and the class of the functional dependence of the control on the current observed value of the state or the current time of observation. And particularly, the case of discrete feedback is analyzed using discrete observation of the phase state of the object at its certain points. The constancy of the parameters of the zonal control actions determines the robustness of the control system. It also ensures the feasibility of synthesized control actions with a sufficiently high accuracy and improves the technical performance of the equipment which is involved in the control loop. The principle of zoning of control parameters has been used by us at the basis of numerical methods for solving such specific optimization and inverse problems are the problem of optimal placement of production and injection wells and optimal control of their flow rates during the operation of an oil reservoir under the regime of water-driven piston displacement. And the references will be given at the end of this presentation. The problem of identifying the hydraulic resistance coefficient under unsteady flow of viscous fluids through main pipelines, as well as problems of synthesis of control and identification of objects with lumped parameters. Let's start with the problem statement. To illustrate the proposed approach, we consider the problem of controlling a rod heating process by means of lumped point sources. So this process can be described by the following parabolic type differential equation 1. Here 0, 1 is the segment that is occupied by the rod. So we consider a rod of length 1 just for convenience. Then xj, this is a x dash, the points at which heat sources are located, and these heat sources have optimizable powers, which we denote by theta j. Then m, here m is a given number of heat sources, and delta is a one-dimensional generalized Dirac's function. And a squared is the thermal diffusivity coefficient, and u itself is the function of xt that describes the temperature distribution along the rod at any moment of time. And t, it's the duration of the t, capital T, the duration of the process. Now, initial and boundary conditions are given in the following form. So here, G0, the G0 of x, G1 of t, and G2 of t are point set mappings for which each value of the argument is associated with a closed bounded set. As you can see in this statement, the initial and boundary conditions are not specified, but we only know that they belong to some given sets, G0, G1, and G2. So the corresponding distribution functions, phi0, p1, p2, are given, which characterize the distributions of possible values that the initial and boundary conditions can take. Assume that thermal sensors are installed at n points of the rod with coordinates in order to measure the current temperature along the rod. These sensors realize operative observation and input to the control system of information on the state of the heating process at this point, which is determined by the following vector. U tilde, asterisk, as usually denotes the transposition sign. In addition to the discrete points, we have the discrete points of observation, time, tau I, at which it is possible to measure the object state at the points of the rod where the thermal sensors are installed. So to control the heat conduction process, it is required to synthesize a regulator that, based on the results of temperature measurements taken at these observation points, x tilde, would ensure the maintenance of the temperature at the final moment of time at a given level by adjusting the temperature in the heat sources. Based on technological conditions, we have to impose certain constraints on the values of the controlled, that the controls can take. This is how we denote the possible, the set of possible values of the controls by BG. Here BG is the set of permissible values of the control. Now, the considerate feedback control problem for the rod heating process consists in choosing permissible values of the source's powers as a function of the object state. This is how we establish the feedback, that is a connection between the power sources and the current state of the object at the observation points, U tilde. The observed points of the rod in order to minimize some given function. And now, in the case of non-fixed initial and boundary conditions 2, 4, the functional objective functional can take on the following form. So here U, this parameter, is a solution of the problem 1 through 4, corresponding to specifically chosen initial and boundary conditions. That is described by functions G0, G1, G2, and to permissible values of the control theta of t. Then U carried is the given function characterizing the desired temperature distribution at the final moment of the heating process. This functional 6 characterizes the quality of the process control on average of the sets of all possible initial states and boundary conditions. Now let the phase state values of the rod satisfy the following inequality. Let's say that we have information about the minimum and the maximum possible values of the temperature inside the rod under all possible permissible values of the controls, initial and boundary conditions. So given the points UK, we divide the range of all possible temperature values into M temperature intervals, non-intersecting temperature intervals. In the n-dimensional phase space of the current measured temperature values at the points of the rod, we introduce the following n-dimensional parallelepipeds, or so-called DOMs, the total number of which is m to the power n. I denote the n-dimensional multi-index, which determines the number of the corresponding parallelepiped. The values of the controls, theta, constant for this time interval from tau I to tau I plus 1, are determined depending on the last measured value of the observation vector over the current object state, U tilde, namely, depending on the number or multi-index of the parallelepiped A to which the last measured object state, U tilde, belongs. To each phase parallelepiped, there corresponds its own constant control value, depending on the number in the form of 9. If the observed object state belongs to the border of any zones, then we make use of the value of the zone control, that adjacent zone into which the trajectory has passed, and the number of different values that the power of each source can take is equal to the number of phase parallelepipeds, that is m to the power n. And in this figure, you can see the possible configuration of phase parallelepipeds in case when there are only 2 thermal sensors installed along the road, along the length of the road. That is, there are 2 thermal sensors installed at this point, x1 tilde and x2 tilde. And the phase parallelepipeds, in case of 3 thermal sensors installed, may represent, for example, cubes, etc. It is clear that the controls 9, like 5, assume the presence of feedback. In the case of 9, the values of the powers of the control sources during the rod heating process change only at the moments when the population of states at the observed points proceeds from one phase parallelepiped to another. And the total number of optimizable parameters is thus equal to m times m to the power n. Again, here m denotes the total number of heat sources. They determine the behavior of the sources under all possible states of the rod at the observed point that can occur under various admissible initial and boundary conditions and control actions, on which depends the belonging of the current state U tilde to one or another phase parallelepiped aid. Thus, they consider it problem of controlling the rod heating process on the class of piecewise constant functions with the use of feedback consists in optimizing this m-dimensional vector theta. So essentially, we have reduced the infinite dimensional optimal control problem to a finite dimensional optimization problem. They consider feedback control problem 1 through 9 as a parametric optimal, we call it has a special name, parametric optimal control problem for a system with distributed parameters. Its specific features are as follows. Firstly, the absence of specifically prescribed initial and boundary conditions in the form of 2 through 4. Then secondly, the finite dimensionality of the sought for control vector. And thirdly, the control is formed depending on the values of the current state of the process at the measurement point. And more precisely, it depends on the multi-index defining the parallelepiped or zone of the phase space to which the current measured values belong. The solution of the control problem in the considered formulation are synthesized zonal controls, provided that the feedback with the object and the choice of the values of control actions is carried out at specified discrete moments of time. As examples of practical applications of such problems, one can cite the control of many technological processes and technical objects, the organization of continuous monitoring of the state of which is impossible, and each observation requires certain measures and therefore costs both time and material. The formulated problem on synthesis of zonal controls leads to a finite dimensional optimization problem, as stated above. For a numerical solution of this problem, we propose to use the approach described in this reference 7. To solve the problem, in the case of a simple design of a set of admissible controls, V, for example, in case V represents a parallelepiped, a hypersphere, a polyhedron, etc., it is effective to use gradient-based numerical optimization methods such as the gradient projection or conjugate gradient projection methods. For example, for the conjugate gradient projection method, we construct a minimizing sequence theta k in this way. More details are provided in these two references. Here, the superscript k, that is index k, denotes the iteration number. Then theta 0 is some admissible initial approximation of the optimized vector. Then this quantity, del g of theta k, the gradient of the objective functional of the problem. Then alpha k is the step size taken to the minimum of the objective functional in the direction of the vector sk. And here PV is the projection operator onto the admissible set V. And if the domain of admissible controls have a complex boundary and the projection operator onto it has no constructive character, then to solve the posed problem, one can use methods of sequential unconstrained optimization, like the methods of internal and external penalty functions, with the use of effective methods of unconstrained optimization of the first order, such as quasi-Newton methods, for example, the David and Fletcher power method. To construct iterative methods based on the above optimization methods, it is important to have exact formulas for the components of the gradient of the objective functional in the space of the optimized parameters of the zonal controls. To this purpose, in the work, we derive formulas for the gradient of the objective functional in the space of optimizable parameters. And the derivation of these formulas is based on the technique for calculating the increment of the objective functional obtained by incrementing the optimized parameters, as well as on the technique for obtaining the necessary first-order optimality condition for systems with variable structure. So we denote by P the time interval during which the vector U tilde belongs to a phase parallelepiped under the chosen values of controls and initial and boundary conditions. Consider the following. We consider the following boundary value problem, which is conjugate to 1,2,1,4, and then comes a theorem that provides the formula for the gradient of the objective functional with respect to the optimizable parameters. Indicator 14. So then comes the algorithm of the solution. I will skip this part. So the quality of the control system with the use of zonal control actions described above is significantly affected by the choice of both the number and specifically the structure of the zones themselves. It is clear that an increase in the number of zones due to their refinement can only lead to a decrease in the value of the objective functional. On the other hand, an increase in the number of zones leads to the fact that control actions can change their values more often in time, and therefore, on the one hand, the robustness of the control system deteriorates, and on the other hand, this leads to rapid wear and failure of the actuating mechanisms. Conversely, an increase in the size of the zones, that is a decrease in their number, on the other hand, worsens the controllability of the object, and with a small number of them, the object may become completely uncontrollable. On the other hand, this increases the value of the objective functional, that is, the quality of control deteriorates. Taking these issues into account, the following approach is recommended, in which at first an initial value of m is arbitrarily selected and some zones aid are assigned. Having solved the above control synthesis problem in the form of a finite dimensional optimization problem, we can carry out the analysis of the computed optimal zonal values of the controls for all neighboring zones. If the optimized parameters in any two adjacent zones differ by a sufficiently small amount, then these adjacent zones can be combined into one, thus reducing their number m, and hence the number of switchings of the control. If the optimized parameters in two adjacent zones differ significantly, then on the contrary, each of these adjacent zones should be divided, for example, into two zones. This leads to the increase in the number m, and again we have to solve the considered control synthesis problem. An increase in the number of zones should be carried out until the value of the objective functional ceases to change significantly. Now, so several remarks about these problems. The frequency of observation times should be such that while the state of the object belongs to any zone, at least one observation is made. The second remark, the main issue with the proposed approach to organization of feedback is the high dimensionality of the optimizable control vector. The dimension of the optimizable control vector represents a power function with respect to the number m of temperature intervals within the range of all possible temperature values of the object. And on the other hand, it is an exponential function with respect to the number of thermal sensors installed along the length of the rod. Beside that, the number of thermal sensors also affect the dimension of the optimizable control vector. It is known that one of the basic problems of numerical optimization techniques of any order is the computation of optimal solutions of high-dimensional objective functions. This is because optimization of high-dimensional objective functions is computationally expensive and cost-involved, especially when we are seeking the global optimal solution. This kind of problems are characterized by many parameters, and many iterations and arithmetic operations are usually needed for evaluations of these objective functions. In order to speed up the evaluation of the objective functional in the post-optimal feedback control problem, we can make use of the inherent concurrency which is present in the form of the objective functional. Namely, because the evaluation of the objective functional involves computation of definite integral seeks, knowing that the elements of this set G0, G1, and G2 are independent, we can easily parallelize its computation by assigning to each thread a process a specific triplet of functions g0, g1, and g2, and computing the innermost definite integral in 6 with a sufficient high accuracy. The innermost integration can also be parallelized if a preliminary slice the interval 0, 1 or 0L in the general case into several non-overlapping subintervals and computing the definite integral over all these subintervals concurrently. The same concurrency pattern also applies to the evaluation of the gradients of the objective functional according to the formula 14. Note that the solution to both the direct and adjoint initial and boundary value problems with respect to the parabolic type differential equation can be easily parallelized to if we employ an explicit finite difference scheme to their solution, although it is not advised. Even if we employ implicit finite difference schemes to their solution, we will still be able to parallelize computations using efficient iterative methods of solution to linear systems with banded coefficient matrices. And at the conclusion, in this work, we have obtained formulas for the gradient of the objective functional in the problem of synthesizing feedback optimal contour problem for objects described by a system of partial differential equations given inaccurate information on the values of the initial and boundary conditions of the object. The formulas obtained make it possible to apply first-order finite dimensional optimization methods for the numerical solution of their problems. It is known that the technical implementation of piecewise constant synthesizing functions with a sufficiently high accuracy is relatively simple. Therefore, the proposed approach to solving optimal control feedback problems can find wide application in automated systems and automatic control of systems in the presence of inaccurate information on the state of the object. The object of application can be many controlled mechanical systems, technological processes described as systems of nonlinear differential equations. And note that the proposed approach can easily be extended to 2- and 3-dimensional heat conduction processes. And they are the reference that I've used in my work. That's it. Thank you very much. If you have any questions, please.
Thank you, Professor Guliyev. Please, if you have the questions, you can ask. And thank you for the presentation about the direct applications of the HPC systems in the industry, in the industrial problems. And it's one of the main directions of our HPC Center. And I want to inform the participants that this paper will be published in the next issue of Azerbaijan Journal of High Performance Computing. So you can find more information from the journal.
Thank you, Dr. Hamid. Thank you very much.
Thank you. I think we can wait for 1 or 2 minutes for the questions. I see that we have not the questions and the comments. That's why I want to ask Tapalina for introducing the next presentation, next presenter.
Thank you, Nigar. Our next presentation is on the topic just a study of the effect of the parameters for optimizing profit using simulated annealing to solve shelf space allocation problem by Professor Romit Bid, Ankita Sarkar, Raya Sinha, Debushuti Dasgupta of St. Xavier's College. Are you there? Ankita, Raya? Deboshuti?
Yes, ma'am. Present. I'm currently presenting the screen. Good evening, respected dignitaries, teachers, and fellow students. My name is Ankita Sarkar, and today my teammate Raya Singh and I are going to present about our project, a study of the effect parameters for optimizing profit using simulated annealing to solve the shell space allocation problem. This project is done under the guidance of Professor Romit S.P. Abstract. For any retail store in concern with all the types of consumer goods, shelf space has always been a crucial issue. This is because shelf space in a store is a limited resource. Our main objective is to allocate products in a shelf in such a manner that maximizes profit over objectives and constraints. The consequence is a non-linear programming model having a complex objective function. To solve such a problem, we have used a hyper-heuristic approach for the allocation of products using simulated annealing. For this project, we have improved the simulated annealing by including multiple neighborhoods and also included an annealing space. Various parameters of simulated annealing have been studied in this paper, which provided optimum values for maximizing the profit. Introduction. So, what is shell space allocation problem? The shell space allocation problem is defined as the distribution of appropriate shell space among diverse products along with their locations in a store, such that the total profit as well as the purchaser fulfillment are maximized. Now, what do we mean by shell? A shell is defined as an horizontal, stable, and quadrangular structure which is used to withstand, hold, and display products, whereas a rack is defined as a stack of shells. An intelligent product arrangement on the shelves becomes essential to increase the perceptibility, consumer responsiveness, and demand of the product, in turn, resulting in better performance. The objective of shelf space allocation problem is to maximize category sales and profit without any restriction, that is, retailer's profit, or to improve the sales of any particular brand, thus wanting to allocate as much space as possible to one particular product, that is manufacturer's good. In our paper, we concentrate on retailer's perspective to allocate shelf space to maximize the profit. A problem of such nature whose decision variables have discrete and finite domains is termed as combinatorial problem. Combinatorial problems has finite number of solutions, although it has exponential number of variables. In such case, we have more than one feasible solutions that satisfy the problem constraints. Optimization problems helps us to obtain better solutions compared to other solutions, which is mostly evaluated using objective function. For this project, we have chosen simulated annealing to solve the mentioned objectives, which has been further improved. So why we have chosen simulated annealing? Simulated annealing was inspired from the physical process of annealing of metals. It is one of the best known local search techniques. A local search technique is a type of heuristic algorithm that searches approximate solutions in small computation time. A major advantage of simulated annealing is that it never gets trapped in local optima. Such an advantage is very useful in such complex problems. Again, simulated annealing can be used to solve NP-hard problems, that is, problems that cannot be solved in polynomial time. Another feature of assay is that it is probabilistic in nature. Assay is highly sensitive to the annealing schedule, that is the initial temperature, final temperature, and the cooling coefficient. Again, assay is also sensitive in the way that the neighborhood is searched, that is, the moves in the neighborhood affect the results produced. But large runtime is a major disadvantage of assay. Assay is mainly used to solve a single objective problems, but it can be extended to multi-objective problems. The triumph of assay lies in the ease of implementation, application, and testing. To give a basic idea of how essay works, we have taken a short video which is not included in the actual paper. Consider the graph as shown here. This plots all the feasible solutions on the x-axis and against the fitness values taken on the y-axis. Essay starts with a random initial solution. This is considered as the current solution denoted by the blue dots. Essay then generates a random solution from the neighborhood of the current solution denoted by the green dot. Then it checks if the generated solution is better than the current solution. If yes, we readily accept the solution. Again, if it is the best solution, we store it as the best solution denoted by the red dots. If the generated solution is not good, it is then accepted with a certain probability and made the current solution. This process continues until the annealing process is complete. Now, for any problem formulation, constraints can be split into two types, hard constraints and soft constraints. Hard constraints are defined as the restrictions that cannot be violated. Their violation prevents the solution from being visible at all. So, it can be said that hard constraints define the boundary of the search space. For example, in our case, we cannot allocate items to a particular shelf such that the total items in the shelf exceeds the total length of the shelf. Now, soft constraints are those which can be violated but at the price of higher solution cost. Hence, care must be taken to minimize these kinds of violations by optimizing the process. For example, in our case, we know a certain product gives very high profit, but this cannot be the sole reason to give it an entire shelf. So, for a given product, there should be a cap on maximum number of facings it has. Now we define a multi-objective optimization problem. A multi-objective optimization problem combines several objectives that decide the ultimate outcome. These objectives influences one another in a complex and conflicting manner. Again, there is no distinct solution that minimizes each of the objectives at the same time. After obtaining the solution, multi-objective optimization problem aims to compare the obtained solution and measure the improvement with respect to the other obtained solutions. Several conflicting objectives may be framed into a single objective scalar function as shown in the slide. This is done using the weighted sum technique. Here, Wi denotes the assigned weights and Fi denotes the ith or single objective. Again, the sum of the assigned weights is 1. We have conducted various literature surveys and our observations are mentioned as follows. Hodgson and Evanson in 1969 observed a relationship between shelf facings and states. Fox in 1970 established a relationship between facings of shelf and seats. Derris et al. In 1994 studied the affinity among various products where it was observed that affine products when kept together resulted in a boost in seats. In 1981, a model was presented by Hodgson and Doyle in which they used geometric programming along with heuristic constraints for optimization. A simplified version of Hodgson and Doyle using knapsack approach was presented by Young and Chain in 1999. Russell and Urban extended the Young and Chain model by including the category management in 2002. In the same year, a model using branch and merge method was presented by Murray et al. Simulated annealing was proposed by Kirkpatrick et al. In 1983. Simulated annealing was applied to various problems, including traveling salesman problem by Wang et al. In job shop scheduling by Lahagonet et al. In 1992, and shelf space allocation problem by Errol et al. In 2015. Now Raya will continue with the problem formulation.
Thank you, Ankita. Good morning, everyone. Now, after knowing what the shelf space allocation problem is, as described by Ankita, and having a basic idea, we can dive into formulating this problem. First and foremost, we need to know the inputs to the problem. all the details of the items that are to be allocated on the shelves of the retail store, and also those of the shelves serves as the user input to our problem. In order to find the profit or gain, we must know the selling and the cost price of each item, the length and height of each item, number of shelves in a rack, total number of items to be allocated, along with their length and height, and minimum and maximum number of facing for each item. Here, what we mean by facings is the amount of display area that is to be allocated for each item, which can be seen directly from the shelves. It is also very important to know the affinity of one product to another. That is, let us think of an antivirus software and router, or shampoo and a conditioner. Such products, when placed together, enhances the sale of each other and thus can be considered profitable. While there can be other products, for example, a toothbrush and notebooks, which should not be placed together. These kind of relationships between products is known as affinity of one product to another, or the cross elasticity among the items. Not only does it help in products categorization, but also to promote better gain for the retail store. The mentioned user inputs has been shown in a tabular form. It can be seen that for each item we have taken the mentioned inputs that has been obtained from the retail store, which depends on the retailer's choice and mostly on the customer's transaction history. The scale factor is used for formulation of the demand function. The space elasticity is the measurement of the impact of the product's sale performance by increasing or decreasing its allocation of space. Cross elasticity, as stated previously, is the affinity between the products. Here has been taken between -1 and 1, both inclusive. Cross elasticity closer to 1 between two items means that they are more affine, or they hugely influence each other's sale in a positive way, and thus must be kept closer to each other. While in cases where it is closer to -1, must be kept far apart, and when it is 0, the affinity between the products are indifferent, which means keeping it close or far apart won't have any effect to their sales. We have considered 29 such products that needs to be allocated to 5 shelves in a rack. Shelf space allocation problem is a multi-objective optimization problem. This is converted to a single objective by weighted sum technique. Here, the objectives, demand of an item and selling price of an item, are conflicting to one another. The items with less selling price usually have high demand. Also, the factors affecting the demand of each item are number of units displayed, affinity factor, and shelf location of the item. Increasing the number of units displayed makes the customers more probable to buy that item, thereby directly affecting profit. While this can be effective, the amount of display for other items on the shelves, hence may adversely affect others' profit. Also, the product affinity factor affects the sales of the products and hence has some effect on the profit. Another important factor that can affect the demand is the location of the shelf where the items are put. For example, if a shelf is at eye level, then the items on that shelf will obviously have more demand than those that are, say, on the lowest shelf in the rack. So a survey has been conducted on these factors for customers' choice, taking the opinion of 60 customers of a retail store. From this table, we could see that most votes were given for the selling price. This means the selling price mostly affect their choice. Next comes the shelf location, followed by affinity factor and items displayed. Based on this, we have assigned weights W1, W2, W3, and W4 to these factors, which will be used to formulate the problem's objectives. Now we can come to the objectives of the problem. The main objective is to maximize the retailer's profit. This profit, as explained before, is directly affected by the selling price of each item, PI, and the demand of each item, FI. The demand function is created based on the number of facings, affinity factor, shelf location to which the weights are multiplied in order to make it a single objective. In order to find the total number of facings allocated to the item in a rack, we need the length facing xij and the stack coefficient pi ij. Stack coefficient is the number of products of the item that can be stacked on top of each other, which depends on the height of the rack and the height of the item. In order to find the location effect of each item yi, the location effect of the shelf, stack coefficient, cross elasticity, and the number of facings is required to be calculated. Our objective is subjected to certain constraints. First, the length of facings of all the items allocated to a shelf should not exceed the length of the shelf. Similarly, all the items stacked on top of each other on a shelf must not exceed the total height of the shelf. The maximum and minimum number of facings has been taken as input is a bounding limit in constraint 3. Constraints 4, 5, 6, and 8 defines the relationship between length facings and height facings. And constraint 7 is a cluster constraint which ensures that same type of items have to be displayed together on a shelf. Our problem is solved with an improved version of simulated annealing. This algorithm has 3 main parts where the improvement is focused on. They are the neighborhood structure, learning period, and annealing reheating phase. Simulated annealing uses a single neighborhood structure, but we have taken 6 neighborhood structures, considered one at a time to produce a neighboring solution. The selection of these neighborhoods are done stochastically. The considered neighborhoods are the following. Exchange facing. We'll take 2 random items from the same cell and swap one shelf length facing of the 2. Alter shelf neighborhood will randomly consider an item and move all the facings of a selected item from one shelf to another. Switch neighborhood swaps the total number of facings of one item which is placed on a shelf with another item placed on a different shelf. Increment facing adds one shelf length facing of an item. Similarly, remove facing deletes one shelf length facing of an item. In duplet swap, 2 different affine items placed on 2 different shelves is put in place of 2 poorly affine items sitting together on another shelf. This increases the affinity between the products and removes any undesirable placements. Next comes learning period. Learning period has a huge influence in selection of the neighborhood structure at each iteration. Learning period refers to the time period that the algorithm takes to understand the problem space so as to obtain better selection of the neighborhood moves, which can be then accepted or rejected by the simulated annealing acceptance criteria. During this time, the algorithm iterates to analyze different neighborhood moves, and based on their performance, it gives preference to each of them. The performance of each neighborhood is judged based on the number of new solutions accepted or rejected that are produced by each neighborhood before. The most preferred one becomes the most probable neighborhood that would be randomly selected the next time. Another improvement done is by introducing annealing and reheating phase. Temperature plays an important role in simulated annealing. This temperature is modified in a similar way as in annealing in assay. However, in this improved assay, a new process of updating the temperature is used, that is reheating. During the annealing process, the temperature gradually reduced if we get an acceptable number of new solutions. However, when the algorithm fails to generate better solution, the reheating phase is triggered. That is, the temperature is increased to explore other neighboring solutions in an expanded problem space. Now, we will discuss our analysis on the results. Several runs of the algorithm was performed and outputs were noted in a tabular form, which are analyzed. A snippet of this table is shown here. Firstly, we have plotted iterations to the profit ratio or the profit improvement. The trend of this graph is linearly increasing. It is observed that increasing the number of iterations increases the profit, but at the cost of execution time. From the above graph, it is observed that if the number of iterations is very small, from 4,500 to 20,000, the improvement is minimal. Now between 80,000 to 2,50,000, the graph shows variability in profit improvement. The maximum profit is obtained between 3 lakhs to 4 lakhs, but with some undesirable variability. This indicates practically infeasible increase in profit. The profits obtained within the stabilized range, although is not maximum, but is acceptable enough. The total number of iterations in this work has thus been taken 6 lakhs to give a realistic profit increment. Next, we have analyzed the working of learning period. Learning period tries to increase the profit for a given number of iterations by giving chances to different neighborhoods. A range of different learning periods between 500 to 3 lakhs have been considered. From graph 2, we observe that the number of variations is less than acceptable. This occurs as learning period cannot give enough time to examine the working of each neighborhood. Even though a few times it learns the neighborhood, it is not able to apply it for a longer period of time. In graph 3, we can observe that the graph is almost stable for the entire duration. This is because even if the learning period concludes that a certain neighborhood works best, it will not give enough time to apply the neighborhood to get desired results. So the variation is more or less than the previous one. Initially, whichever neighborhood it takes, it continues to work with it for most of the duration, thus giving a practically infeasible result. Finally, we consider learning period 20,000, which is the trade-off between learning period, learning time, and the application of the learning. This is because the number of variations is more as it is able to find a better neighborhood for a desirable number of times. And also the learned neighborhood gets enough time to be applied to get practical or feasible results. Now Ankita will continue with further analysis.
Ankita, you are muted. Please unmute yourself.
Sorry. Thank you, Ryan. Now we analyze the effect of acceptance ratio. Acceptance ratio RE is the ratio of the number of acceptable solutions for a given temperature with the total number of solutions generated for that temperature. We need to perform a threshold ratio which determines whether to perform annealing or reheating. When RE is above the threshold ratio, we perform annealing in accordance to SA. Now coming to the graph, it is evident that with an increase in RE value, the average annealing also decreases. Now, we know that every time the acceptance ratio falls below the threshold ratio, the temperature switches to reheating phase. This means that we are giving a temperature high temperature nearer to the current temperature a further chance to explore the problem space. This property of modified SA tries to overcome the disadvantage of the traditional SA algorithm. From the graph, it can be seen that with an increase in RE values, the amount of average reheating increases. Now, comparing the two graphs together, we can clearly see that when RE is less than 0.23, it means all the iterations we are getting an adequate number of acceptable solutions. This may mean that we are not minutely exploring the search space. From the graph, it can be inferred that when RE is greater than equal to 0.23, we get a desirable combination of annealing and reheating. Again, it is observed that if we increase the value of RE too much, that is greater than 0.28, there is a high variance in both the annealing and reheating phases, which makes us difficult to make any inference. So, by saying that too much of both either annealing or reheating is not good. Instead, both should be done in moderation. Thus, from both of this graph, we can say that when annealing occurs most of the time, reheating is only done a few times. However, from RE equal to 0.23 to 0.28, it is observed that the number of times annealing occurs decreases, the amount of reheating increases almost linearly. So we can say annealing and reheating is a vice versa process. Now we have plotted RE values against profit ratio. We define profit ratio as the difference between the initial and improved profit to the initial profit. From the graph, it is observed that when RE is too low, that is around 0.1, we are getting a hike in profit ratio, and also when RE is 0.23, the same thing happens. These profits can be termed as outliers, that is impractical increment in profit. But against RE values 0.23 to 0.28, the profit obtained are quite stable and is desirable. The acceptance ratio also influences the execution time. This is because on the basis of acceptance ratio, each time the algorithm decides whether to perform either annealing or reheating, thereby affecting the execution time. From the graph, when RE is between 0.23 to 0.28, the execution is timeless compared to the other positions. For other values of RE, even though we get a higher profit ratio, but at the cost of execution time. At RE equal to 0.23 to 0.28, it is considered as a trade-off between execution time and the profit. So we can say that from a study, we have found the values of number of iterations to be 6 lakhs, learning period to be 20,000, along with an acceptance ratio of 0.25 as suitable to solve our problem in order to get an optimal result. Finally, we conclude by saying that the described shell space allocation problem usually involves a large set of parameters. Obtaining a reliable estimation of such parameters is generally challenging and time-consuming. The results can be used to plan marketing or advertising or for designing layout of a new store. The problem of allocating shelf space was solved using a novel approach which has been analyzed and has been observed that optimization problem is highly sensitive to the parameters chosen. Thus, the found parameters helps us to find an optimal increment in profit. This work can be further extended to include the Pareto optimality to wholly implement the multi-objective problem. Further, the selection of the neighborhoods can be based on a learning mechanism as the selection process might provide a slightly better result for the given instances. These are our references. Thank you.
Thank you, Ankita. Thank you, Raya, for very well. And also I want to thanks to Professor Romit Bid for guiding this work. If you have any question, please ask. If any one of you have any question, please ask. Ankita and Raya, kindly submit your extended version of this work for the publication to Azerbaijan Journal of High Performance Computing. Kindly
Thank you.
submit it.
Okay, ma'am.
Thank you. I want to say thank you to our presenters. Thank you very much for the interesting presentation. Now I want to introduce you the one of the partner organizations of industrial partner of our HPC Center, Other Space, Other Cosmos Space Agency. I want to introduce the researcher from Other Cosmos, Imran Ibrahimli. Please introduce your presentation.
Hi everyone.
Hello.
Is the microphone okay?
Yes, we are. Yes, we are hearing you. We can hear you.
Thanks for the introduction. My name is Imran. I work at the AI team at the Research and Development Center of Other Cosmos, which is the primary satellite operator of Caucasus region. So our team's efforts, which are relevant to the conference, are focused on the image processing and machine learning applied to the images from the Other Sky satellite. So the Other Sky satellite produces images with 1.5 meters of spatial resolution, and about the imaging frequency in temporal space is about 2 times a day. And using these images, the images are multispectral, which means they have 4 channels. That's red, green, blue, and near infrared. And so in order to process these channels, these images with a large number of spatial bands, we actively use the HPC Center of Azerbaijan State Oil and Industry University, which has been kindly provided to use by our team, by the university. And this HPC Center has a number of benefits which make our work possible and make our job easier, so to speak. So first of all, I'd like to introduce one of our projects, which has been made using HPC Center of the Azerbaijan State University of Oil and Industry. That project is called Greenhouse Recognition on Multispectral Satellite Images. So that project is focused on detection of pixels that belong to greenhouses on images from the Other Sky satellite. And so in order to do that, we apply machine learning techniques. In particular, we use computer vision algorithms such as UNets. Yes, so these images have a very large file size, which makes processing those images quite difficult on our computers, let's say. So the HPC Center, which has lots of RAM and also is equipped with NVIDIA 1080 GPUs, helps us quite a lot in that sense, because we use machine learning frameworks like TensorFlow and Keras. And as you might know, machine learning is a very computationally heavy task, and it's also quite parallelizable workloads. So we can use GPUs in order to process our data faster and get results quicker. And the NVIDIA GPUs, which are present in all the servers of the HPC Center, are equipped with CUDA framework and the cuDNN libraries, which allow us to use machine learning algorithms in a large scale. So I can show a few slides from our project. Excuse me. Can I share a screen? Okay, so I'll continue this way for some technical difficulties. I'd like to talk about the input of our machine learning pipelines, so to speak. So the input is satellite images, which are quite large. Let's say they are usually a few gigabytes each image. So the reason for their large file size is because, unlike regular images, which consist of pixels, where each pixel has red, green, blue value, and each value goes from 0 to 255. The satellite images usually go from 0 to, let's say, 4096. They're on 12 bits instead of 8 bits, and also they have more bands than a regular image, more channels. That is, they have red, green, blue, and near infrared, as I mentioned before. So in order to process these images, we have to use a process called tiling, where we take the image and cut it into smaller tiles in order to fit into our into the CPU memory and also into the GPU in order to process them. And also, this processing involves a few steps, which are converting of vector data to raster data. That is, we have images and also we have shape files. Like each greenhouse is denoted by a polygon, so we also have to do some pre-processing steps in order to convert that polygons into binary masks, which consist of 0 or 1 and have this have the same shape as the image. So after that, after pre-processing, we also have to do tiling in order to cut the image into smaller tiles, where each tile may have a spatial size of 64 by 64 pixels or 128 by 128 pixels. So after dividing into tiles, we have our batches, which are the input of our machine learning model, which in this case is UNet. UNet is a convolutional neural network. It's fully convolutional. That means it only features convolutional layers and does not have any fully connected layers. It has an encoder and decoder blocks. So it's an encoder-decoder architecture with skip connections between each encoder block and its corresponding decoder block. So in order to train this large model, we have to use GPU, because on CPU it's quite impractical. It's nearly impossible. And this model has this large size because of the size of its filters, which are 128 filters, and they are doubled on each encoder block. We have 3 encoder blocks, so that's quite a large number of parameters. And this kind of workloads are quite easy for GPUs to process because they are parallelizable. There are actually some matrix multiplications and some element-wise operations on tensors. That's why the use of GPU and some parallelization software like MPI or OpenMP is crucial in the case of machine learning on especially large images. So after the model has been fed with the input batches, we train a model using stochastic gradient descent, as is very common. And we use a validation set and a separate test set, which consists of images that the model has never seen before. So after the model has been trained on these images, the raw output of the model is a binary mask of the same size as the image tile it has been provided with. So we also need to convert that binary mask into the polygons to be used by other teams at Azure Cosmos. And by polygons, I mean vector data sources like shapefile or GeoJSON or something like that. So in order to do that, we also use some algorithms which are easily parallelizable, such as blob detection, where if you have a mask and you have some values which are 1 and other values which are 0. In our case, 1 is foreground and 0 is background. So in this case, we also use algorithms on the GPUs provided by the university in order to process that data into a vector format and provide a complete product which other teams can integrate into their workflows and daily pipelines. So after the model processing has been done, we evaluate the model and test set, which consists of images that the model has never seen before on separate full-size images, which are also annotated by human annotators. So we can provide some metrics such as accuracy, precision recall, area under curve, F1 score. And in our case, F1 score is especially important because accuracy is a biased metric. So if you consider a satellite image, it will have lots of background pixels and very few foreground pixels because lots of majority of land is not used for greenhouses. So that's why if you use accuracy, it's easy to get a high score, but that high score does not correspond to the reality. and that's why it's important to balance, to either balance the classes before training, or if you still have unbalanced classes, it's important to use some metric which considers that imbalance. And in our case, that metric was F1 score. So after the model processing has been done, we usually deploy our model so that other teams can also benefit from it. And this deployment also follows the same pipeline as training. So we use the same frameworks for inference, like TensorFlow with Keras on top of it. And we also deploy our models using a server and a web frontend, so other teams can easily interface with the model without getting into details. So also, our workload is, as I mentioned, it can be divided between different processors, be it CPU or GPU. So it's also possible to use a cluster of nodes instead of a single node, to use a distributed computation, like PyTorch, which is a machine learning framework. It provides distributed backends in order to do that, and also raw MPI instructions can also be used. And this case is actually very important for large-scale machine learning workloads, because there is a limit on how much you can scale a machine vertically. So after some limit, if you run into like memory errors, or if you have processor bottlenecks, you have to scale horizontally instead of vertically, where instead of increasing the memory and the processor capabilities of a single machine, you use multiple machines in a distributed fashion, and you train on those multiple machines as a cluster, where you may have a master node and other nodes use synchronization or some other paradigm. So this project has been completed now. It has been deployed for inference, and as I mentioned, we have used the HPC service provided by the Azerbaijan State University of Oil and Industry. Each of those servers is equipped with NVIDIA GPUs, and that has allowed us to use CUDA and cuDNN libraries, as I mentioned before. So I think this is the end of my presentation. If you have some questions, please ask. Do not hesitate. I'm ready to answer questions.
Thank you, Imran. It was so there was a lot of participants, a lot of students from both sides who are interested in the industrial applications of the HPC, by the industrial collaboration of the HPC Center. That's why your presentation is very beneficial for us and very, very valuable for demonstration of our participants the information and knowledge about the applications of HPC in the industrial organizations such as the space agencies, etc. And if you have questions, you can raise your hand and you can ask questions. And I want to give just one information, that this workshop, we plan to hold this workshop periodically, and on the base of the signed MOU between our university and the St. Xavier's College, Calcutta, by involving different universities, different organizations, partners of the HPC Center, and also the industrial organizations. Now, please, if you have the questions, please ask. As I see, there is no question, and if I will get some feedback, I will contact with you. Thank you very much for your presentation. Now, Topalina, thank you. Topalina, you can introduce the next presenter.
I think we need to wait for a few minutes. He will join soon. Next speaker, next presenter.
Okay, Topalina, if you want, the presenter, the Elviz Ismayilov, can start now, and after him, or can we change the places?
Yes, you can.
Okay. Elviz Ismayilov, if you hear, please Now, I think that Etibar is the PhD student of the Azerbaijan State Oil and Industry University, and directly he do his research in the HPC Center. Now, I want to ask him to introduce his speech.
Hello to everyone. Thanks for everything you. For such a great meeting, and for so I will start to present my presentation now. Let me share it right now. I'm sorry, it seems like there is something technical issue because the PowerPoint is not loading yet.
Etibar, can you share your screen? Maybe it will solve the problem. The desktop.
Yeah, sure. Yes. Sure.
Thank you.
For a minute. Okay, can you see my screen?
Yes.
Okay, nice. All right, I'm Etibar Vezirov, a PhD student at Azerbaijan State Oil and Industry University, and my presentation is about machine learning-based modeling for performance improvement in an exascale systems, and that work is under the supervision of Ehsan Mosavi, who is chief of HPC Center at Azerbaijan State Oil Industry University. Now let's start let me start my presentation here. So let's say what's an exascale computing. First, let's take a look at this. And exascale computing means that the performance of computer systems reach the exaflops level, and kind of 10 to the power of 18 floating point operations per second, and that performance is measured based on the HPL standard, which stands for high performance LIMPAC. And according to the standard, an exascale computer will be 30 times faster than Tiny-2 computer, which is the fastest computer in the world today. And now let me discuss about why we got for exascale today. And based on the statistical information, by 2025, the International Data Corporation estimates that the worldwide data will grow 61% to 175 zettabytes. That's quite a huge number. And so from that time, starting from that time, and even in the current days, from all small private companies to the largest government labs, everyone will be looking for, and now they are looking for the ways to turn this huge amount of data into some meaningful insights, and using combinations of modeling, simulation, data analysis, and artificial intelligence. So the exascale era demands innovation of digital infrastructure, since it can manage large amount of data and support hybrid workflows, and putting together all of them, the simulation, analytics, and machine learning. So, but when we look at the exascale systems, we see that there is a performance problem when we work with different amount of data and different structures. And in traditional HPC systems, the execution pattern designed based on application features and system capabilities. And this pattern is obtained by the designer of computing and processing system. And the elements that form the computing system manager should be able to set this pattern up at runtime. But in the exascale systems, the nature is different. So the existence of dynamic and interactive behavior of the system, the turns the application and the constituent elements of the system change during the runtime. So changing during the runtime makes sense here, and it decreased the performance issue, it increased the performance issue. So that's why, in order to model an application pattern, we use the machine learning techniques. We can use the machine learning techniques as well as characterizing performance data and also classification data, and using some machine learning techniques there. So, so there will be an outbreak in the amount of performance data. So that when we gather data from the different nodes of the applications, so the great number of components will be identified as a potential resources, and that will impact the performance. So the performance analysis of HPC codes requires analyzing enormous amount of data. So in that sense, and they will be generated approximately at the rate of tens of hundreds of terabytes a day, and the enormous volume and variety of data being gathering makes it unmanageable in many cases for a human analyze and also getting insights from them. And so in that sense, we can say that the data-driven approach is must for exascale systems. And fundamentally, there are two kinds of runtime in terms of estimation. And one is underestimated, and two is overestimated. In case underestimated runtime, HPC system terminating the job before it's completing, before its completion, before the application completion. But in the overestimated runtime, results takes longer for the queuing time. So both of them have their disadvantage. So the productivity and efficiency of HPC systems slow down in each case, as we see. And so for this purpose, data-driven approach, which means it actively observes, analyzes, and logs jobs collected from large-scale supercomputers for predicting job status, will be important on HPC systems. And so using machine learning techniques, it will be possible to analyze job data and then build models in terms of various HPC scientific applications. One of the valuable approach found so far is using machine learning based technique, which builds classifiers that can recognize hidden patterns in the collected data. And it will really make sense because we need to understand what jobs are running in the system and the number of resources allocated at each node. So in that picture, you can see there is a three layer, and that's exascale learning in medical image data. So you see that we have three partitions, like patch extraction, deep learning, and solution analysis. And in the first one, we find the patterns there, and then we make localization on large-scale data, and then we output the results over this data. So why it's important to use machine learning in exascale systems? So let's remind this fact that running a 50 million hour simulation on all 684 compute cores on the Cori supercomputers, supercomputer NERSC, would take more than 3 days. So that's really a really great amount of time. And so concerned that running thousands of these simulations would be really uncontrollable. So from this point of view, exascale ExoLearn project, there is an exascale Learn project developed so far, and this project intends to create new tools to help researchers and scientists overcome this challenge by applying machine learning to large-scale experiment datasets and simulations. And the managing team of this project runs thousands of simulations, which ones are computationally high-priced over a large parameter space to train the computer for recognizing patterns in the simulation data. And now let's talk about about the building machine learning model technique. How we can do this step by step right here. So it's highly expected to observe large scientific inefficiency in computational activities. And when we apply high-performance computing experiments at exascale, so if you consider the fact that algorithms, techniques, and some experimental strategies working at lower scales will not be satisfactory at larger scales in order to provide large performance profits in different application domains. The integration of, in that sense, the integration of machine learning algorithms into computations would be an intelligent method, and for predicting failures and finding corresponding pattern there, which is acceptable for us. And in order to predict failures, we utilize the application resources and performance features there. And here you see the steps for building this model, and we can take a look at them one by one in that manner. So steps of building machine learning based model, general model. What we do, at first, we collect a large number of applications with the same number of nodes for offline training. Let's mention this fact that the number of applications can be adjusted, can be more, and the number of nodes in each application can also be adjusted. And then we measure and get some information about the performance and resource usage of the nodes and put them into a data set. And then we calculate the statistical features based on this data set. And the nodes at each application will be labeled as success or failure right after that. And then we use these features. The features we get, the statistical features based on the dataset. We use these features and the labels of the nodes as the input data in order to train a machine learning model. And the most important part is that we can replicate these 5 steps, the previous five steps, until we get an effective and acceptable machine learning model here for us. And now that would be nice to see a mathematical view of this model. We can suppose that there are n applications which we gather for online training, and in each application we can have k nodes. So we can symbolize this like aj from n1 to nk. And for these nodes, we suppose that we have fj and gj indicator functions, one for resource usage and the other for a performance measurement, respectively. And also we will get that mapping, this pi and ri, corresponding to statistical features for these measures. So we apply these indicators and get some statistical features from them. And that will be possible. In that case, it will be possible to derive a general indicator function vector, which is mj, and as well as general static feature vector based on pi and ri. So we can name this as zi. And what we think that the index I will be the label of the node, while the zi will be the feature of the vector computed per node. And so we can take them as input data for building machine learning models during offline trainings. So the key aspect behind this approach is collecting training data, kind of like this, zi and yi for all the zi's. And we suppose that this zi, the set of them, zi is t. This is training vectors, and the d, which is the containing set, which is the full data set for this. And we can define the relation between zi and yi. So this is really important as an input and output mapping respectively, so like input and output respectively there. And if we suppose that the mapping is implemented by the f function like this, yi equals f zi, and this function we said that will be in charge of modeling procedures here. So the purpose of the supervised learning approach of machine learning is to find the deputy function. Maybe age, maybe k, so it doesn't make sense. We can name it in any manner. So let's suppose that there is a deputy function h for f, such that the difference between f and h should be minimal for all the zi's from T set. So that was the mathematical view of machine learning modeling we introduced there. So we can discuss on application, on the application of this suggested model. So to deal with a revolutionary computation of scientific applications with exascale architecture and predicting failures of the different components, this model proposes a spatial machine learning strategy which can be very useful for performance improvement. And it's necessary to have a huge amount of training data and resources in machine learning for an accuracy, conducting an adjustable offline training over the large number of applications. So that will be the good starting point for us, since if we do so much trainings, so we can get more accuracy there. So that will be followed by measuring, calculating, labeling, and finally making decision to predict the best satisfactory model in that strategy. And that would be nice to mention that the integrating machine learning algorithms efficiently to the exascale systems using that strategy may contribute huge profits to medicine, global industry, nuclear energy, and many other worldwide fields, since they are the most important parts, most important research fields in our modern world. So, in order to recap the model for this presentation, we can say that building an efficient machine learning model is by the use of classifying observations at runtime and predicting the failures is most important in today's world, one of the most important things in today's world. And what we do here, we propose an online training for the large number of applications with some number of nodes, and then we gather an information about the performance and resource usage of the nodes and put them into a data set. And this data set will be used for deriving statistical features, and then consequently we label the nodes as success or fail. The remaining job will be training machine learning algorithm with which will accept them as input data, this label and features I mean as input data, in order to build the model. And we can say that that model can be a generic model because we can replicate the 5 steps we mentioned for building the model. And this model can be, we expect that this model can be efficient for avoiding from the failures, since we label nodes success or fail. And so avoiding from the failures, which forced the application performance, which decreased the application performance here. So that was all about my presentation. So here's the references I used during my research. And if you have a question, you are more than welcome to ask. And thanks for your attention.
Thank you, Etibar. Thank you for your presentation. Thank you about the introducing of the exascale computing systems, which is a topic in the HPC systems area.
Thanks a lot.
Questions? No questions. So I think that now we can greet the Mr. or Mrs.
No, one presentation.
Dr. Dr. Siddhartha Roy from St. Xavier's College. Please.
Yeah, thank you for the presenter. Okay, so let me first share my screen.
Please.
Just a minute, I'm just going to share this.
Okay. Okay, don't worry. Now we see your screen.
Okay. Okay. So, is it visible to all of you?
Yes, yes.
Okay, thank you. Okay. So, my topic is automatic number plate recognition using CNN or convolution neural network. Okay. So, let me briefly introduce what we are going to discuss today. Basically the introduction part, then what is the application of NPR, and steps in NPR, license plate segmentation, number plate recognition, and results and simulation. Now, first is automatic number plate recognition. It has been rapid and widespread adopted worldwide to enhance their enforcement, investigates, and security capabilities. This technology helps in collecting the vehicle's information, which reduce tedious and time-consuming manual work. So one of the most important part is the OCR. So OCR is optical characteristic recognition. It is a technology that is mainly used for recognizing the machine printed or human written text in scanned document and images and then convert it into editable fonts. This expanding its application, we can use OCR in computer guided traffic system, in an intelligent traffic system, and that can work on its own with little or no human interaction or intervention. So number plate recognition plays an important role for building any intelligent traffic system, because due to increasing in the number of vehicles, the major problem that arises in the traffic management issue and ever increasing vehicles information which is required to be processed for stolen cars as in traffic rules violations. Hence, it is necessary to have a system that reduces the load on the human operators so that we can capture the image, we can extract the number plate, we have some database, we can easily identify the person, which is very difficult if it is opted for from the human point of view. So what are the main applications? Why it is so important? First of all, to tracking the stolen vehicles, violating the traffic rules, vehicles on connecting with the crimes or other vehicles of interest, private parking lot management, traffic monitoring, automated traffic ticket issuing, automatic toll payment, and deploy. First thing is that we have to plate localization. That means find and isolate the license plate from the captured image by the camera. So we have to extract the particular image. That means we have to crop the particular plate region from the extracted image. After the second point, the second step is that plate orientation and resizing, because the image can be captured from various angles. That may be skewed one. So we have to de-skew it and we have to resize the image as per your requirement, because whenever we are going to capture the image, it can have different sizes. So our main objective is that all the image that must have some same size. And because of the camera capture the image at different angle, the license plate image are quadrilateral, not rectangle. So the de-skew process helps in skew, slant, share connection to the captured image. Third point is image normalization. So first change the intensity value of the image so that it matches the characteristics of the reference image. All images that must have some same intention, same uniformity. And some of the approach includes scaling and histogram equalization. After everything is done, then the next part is character segmentation. What is character segmentation? That will extract the alphanumeric character from the number plate system. And finally, after the segmentation is performed, the next part is, final part is character recognition. So we have to recognize all the license number of the vehicle using the OCR, or optical characteristics recognition. Now, we have done here using this OCR using the CNN or convolution neural network. Then why it is important? Let me first discuss the problem for the existing NPR system. That's why we opted for CNN. First of all, poor image resolution due to low quality cameras. Because sometimes to capture the image, we require high quality camera, and that is very expensive. Most of the time, our existing camera cannot take the picture, and that is very poor quality picture. So how to make it more prominent picture without simply our camera, low quality camera? That is one problem. Second point is that poor lighting and low contrast due to overexposure, reflection and shadow. That is the other problem with the existing ANPR system. Third point is, if it is very high speed motion car, this is the picture image that will be taken, that will be blurred. That is other problem with the existing ANPR system. Next one is lack of standardization format, because if we look at the format, of the number plate, different country has different number plate. There is no standardized format exists. Even in India, each of the card, some of the card they have all numbers within the single line. Some of the card they have different 2 lines. Okay, so and that is some different format. So which will different from state to state, which is different from country to country. So that is the other problem. So that some of this difficulty can be overcome using some software, while some other difficulties can be overcome by some hardware. Okay, so that is our existing scenario, that what happened in the reality. Now, what we do, we first for our work, we just try to extract the image and make it clear image. That means there will be no blurred image. If we take it, we can take the picture, the image will be clear. So first we take the input of an image of a car that goes to the image pre-processing stage to enhance the image quality for better result in later stages. Then we have to convert it into RGB, red, green, blue image into grayscale for further binarization, and that will restrict the color set to 2 colors only visually black and white. And then with the help of the Sobel's edge detection algorithm, we extract the license plate from the binarization point. So after getting the license plate, now the system will segment the character on the license plate by horizontally scanning the image, and then with the help of CNN, we recognize the character, and after recognizing the character, we can use them for verification of license number or extracting the information about the vehicle owned based on the license plate number. So what are the process that is summarized over here? So first we have to acquire the input image, then image pre-processing, that means RGB to grayscale conversion. We have to remove any kind of noise by iterative bilateral filtering, then image binarization. Third point is license plate extraction using the Sobel's edge detection. Fourth one is character segmentation, and finally recognition of number plate or license number using the convolution neural network. So this is the way that this is our few results. That is actual real life result. We have taken the image from the car using the mobile or digital camera. Then we extract the number, that means localization, and then we segment each of the character. Then we are segmenting each of the character. So this is our real life work that we have done. Now, these are all segmented characters. So we are extracting all the segmented character. And this segmented character will be used for training model. This segmented character we are collecting and then we use for the training model. Okay. So, first of all, use our existing system that, as I already mentioned, that may not give the clear combination or clear picture or clear images. So, deep learning in the basically the convolution neural network that will work very importantly for extracting the image, right image. Even if we extract the image that is very blurred, convolution neural network is so powerful that it will give you the correct one. That already we have developed here in our particular work. So suppose we are extracting some blurred image, okay, and segment a blurred image. But whenever we are give the input using the convolution neural network, that will give us the actual text, and that means actual image. Okay. So that's why we are using this CNN or convolution neural network for this part. So as already is mentioned, that deep learning, it has three different popular deep learning architecture. One is ANN or CNN and RNN. So on the basis of that artificial neural network that is used for text-based data, recurrence neural network that is used for time series data, and convolution neural network that is used for image classification, and that gives us very good result. Even in the dark side, even we can extract the image in the heavy raining season, then at that time also it can give you the clear idea. At least 90, you can achieve more than 90% accuracy using the convolution neural network. So what are the basic architecture of the convolution neural network? That architecture consists of various layers such as convolution layer, that is the first layer, and which is used for feature extraction and creating the feature mapping. And then after that we use the pooling layer, reduces the number of weights and control overfitting. Then flatten layer, prepare the output to be fed into fully connected layer, and finally at the top, and then fully connected layer that is used to sum up all the detection made to the previous layer and give you the final output. So these are the four basic layers that is used in irrespective of any convolution neural network. And what we are using here in our work, that I am giving you some idea, that is one is ReLU, that is the rectilinear unit, most commonly deployed activation function. So it will always give any value, it will always give 0 for any negative value, otherwise it will give you the exact value itself. So that's ReLU is used over in our particular convolution neural network. Then we have used ADOM optimizer. There are so many optimizers are there, but we have used ADOM optimizer. Why? Because it is used for stochastic gradient descent training. It is the optimizing algorithm which is used for stochastic gradient descent. And why stochastic gradient? Because in gradient descent that is used to minimize the error function. But whenever we use the stochastic descent, then it will shuffle the image and it will take one image at a time. So it will reduce the time. So ADOM's optimizer is used for, it is the optimizing algorithm that will be based on the stochastic gradient descent. Then third one we have used the loss function as a first categorical crosstalking. Why this we have used? We have used because it will save the time in memory as well as the computation, because it simply uses a single integer for a class rather than the whole vector. And loss function is very useful. Calculated this loss function is very useful because if we minimize the loss, that means it will give you the greater accuracy. EPUB. These are also, it is based on, because it will give you the updated, the weightage, feature extraction weightage, and we achieve to the global minimum. That's why we are using EPUB. So number of EPUB that will be decided by the user. If we find that after particular user, suppose after 10 or 15 users, we find all the values are convergent, then we stop there. So that is the testing procedure for EPUB. So this is the system. So it will capture the image. So actually what's happened, it will capture the image. Then if it is video stream, then what it will do? It will capture the video. Suppose we are taking the video image, then it will simply split into the frame. Then that frame will be processed, the frame, and then locate the number plate and region, and then crop the plate region. So here we are using our system, it will crop the number plate, and then it will give you the output. So that's what our system will do, or what our system will perform. So, but for training part, we can use two things. Either you can use MNIST dataset that is already available in the particular Kaggle dataset. Here, what we are using, we just extract all the segmented data, and we train those segmented data, segmented character obtained from the application. So there will be some OpenCV using the OpenCV function. We just segment the character, and then from those characters collected, and that we were using for the training model. So the learning model that will be used for this recognition must be able to read all the images and render the corresponding character. So in order to make most data available for learning, what we do, we cut each character individually. So after extracting the image, we cut it, we segment it, and square it after applying the same image processing step used before segmentation of the license plate. So for that, we obtain the set of data composed of 26 characters, because we are working on the Indian number plate system. And since Indian number plate system is used in English, so we are taking 26 classes for A to Z number, and for number system that is 0 to 9. So altogether, we are taking 36 classification for the CNN, convolution neural network. Okay. So in our proposed system, what we do, CNN algorithm has the following characteristic. I have already mentioned. The first layer is convolution network we have used for our work. Next two layers are hidden layer, which will take the weighted sums from the first. And after this convolution is done, then ReLU activation function is applied on this layer, which forces the neurons to return the positive value. Okay, because that I have already mentioned. And the last layer uses the softmax function, which represents the probability distribution of the output. And we also use the sparse category custody. Why we have used it, that I have already mentioned. Now, all proposed algorithms were done using Python 3.7 with several libraries such as OpenCV, TensorFlow, and Keras. So Keras we are taking as the front end with back end as TensorFlow. And this OpenCV is used specially in the number plate localization and character segmentation. And TensorFlow and Keras are used for CNN algorithm, which is applied in the OCR phase. And run the environment in cloud environment using Conda 4.511. That is what we have done in our work. So we have used, already I have mentioned that we have used multi-classifier CNN consisting of 26 English alphabets, A to Z, and 10 numerical digits, 0 to 9. And the training needs several images to obtain greater accuracy. Obviously, we need more training data for obtaining the greater accuracy. See, this is the work. You just see, and that we have worked, that you find that K, we have extracted this image. K is very blurred image. But whenever I run this image, it will exactly show you the K, actually exact K, which is not possible using the general OCR technology. OCR fails to detect this K. Our existing OCR using OpenCV, that failed to detect this K. But whenever I'm running this part using K, that will give you clear picture that is K, because that K is already trained. This K is already trained. Even if it is other form of the K will be trained, then it will give you the clear picture. Similarly, the number plate will the same thing that will be followed, and it will give you the same images. It will extract, do. Okay. So initially, we have developed training set database by training different segmented character. We have composed of 1000 images of number figures, where 200, so we are giving just that means 80:20 ratio. So for training part, we have 800 images, and for testing part or validation part, we have used 200 images. Okay. So several tests were done, and we have made this accuracy 95%, which is quite good, which is very good compared to other systems. So this is the simulation result. If you find that this is the accuracy system, this is the loss, one is loss, another is categorical accuracy. Categorical accuracy, initially you find that the accuracy was very low, but whenever we are run it many times, number of epoch used 20, we find that categorical accuracy that becomes more than 95%. And this is the loss. So this is the performance analysis for our work, and actually this is the observation. We find that at 20 demo, loss is 0.4591, categorical accuracy is 0.9583. That means very high. Actually, that is based on the training one. This is validation loss, that is based on the validation data, 0.43, and value category accuracy, that is 1. It's very quite high. Okay. So what we observe that the loss is 0.591, and the validity loss, that is 0.4311. So here, so interpretation is value loss is less than the loss. What is the possible loss? What is the reason? Reason is that we have to use the regularization applied on training, but not on the validation or testing. So possible solution, add in the regularization or loss function during the validation and testing. So it will be more or less would be same. Another part is that the training loss is measured during each epoch, while validating loss is measured after each epoch. So on average, the training loss is measured 1/2 an epoch earlier. So that is our interpretation. It is not always true. Okay, sometimes the training loss may be less than the validation loss. So in our work, we have find this thing, and that is our interpretation of the results. This is the simulation result. So whenever we supplied the model, that means car image. So you find that this is the model, and it will give you, this is actually, it is the real form of the image, how it looks like. Okay, so it will give you WB26X039, and that was based on this time, and this is our results for extracting the image. So this kind form of image will be appear in the particular CNN or convolution neural network. So this is other images. So we have tested all the images. Okay, and this is our result. Okay, obviously not 100% result will be corrected. Sometimes it find there is some difficulty when I am checking that. Sometimes it may find difficulty to extract image S and 5. It looks like S and 5 sometimes look like same. So it happens. Okay, but overall result is performance is very good in our result. So in our preliminary work, we have simulated the result using static image. That means we have just take the image using mobile and digital camera. So we have to further extend it for real-time video streaming. So that we have for real-time video streaming, we have to extract the particular frame, and we have to do the work. Okay, because this is our preliminary work. So in this paper, we have examined only fixed length number plate, only fixed length. Suppose there are 10-digit number in the 10 alphanumeric character in the number plate. So it can only use for 10 alphanumeric character. If I am using 5 alphanumeric character, it cannot segment those things. So segmented, that is our problem, and that means this is our problem in our present work. So what is the drawback of our model that we have to develop? And since this is the preliminary work, lots of drawbacks are there. So in our model, it can segment only single line number plate. It cannot segment 2 lines number plate. Suppose, for example, here the number plate occurs in the 2 lines. So we cannot segment it properly. It will give you some wrong information. Okay, so that is our task that we have to do. Second point is segmentation is incorrect for the images taken from slanting position. What does it mean? That means we cannot discute it properly. So we have to discute it properly. That is our other problem area we have find. We have identified the blurred area. Blurred image it can identify, but whenever this type of event happen, we cannot use that thing. Does not support non-standard format. See, this is non-standard format. Okay, that we cannot support. Okay, so it is MY02. So the length is small, so it cannot extract those images. Okay, why? Because the segmentation, our segmentation does not support this kind of non-standard format. Now, there is other problem, real life problem that we faced that cannot eliminate, because whenever we are segmenting the character, some garbage character will appear. Some garbage character will appear. So how to eliminate this garbage character? Because CNN will classify the model. CNN cannot be used to eliminate this garbage character. So that is the other problem. So what we did that we made other classifier as garbage classifier, and we have to train them. But unfortunately, sometimes they give some wrong results. So that is our problem in our model, because garbage symbol, because garbage means anything, some dot that is also collected as a garbage value. So it cannot give you the proper value. So sometimes during the segmentation, this type of garbage value is appearing, but problem is that our system will not work with this kind of garbage model or garbage symbol. Okay. So what is our work that we have to do? First of all, we have to support all non-standard Indian number plate, then extend it to multilingual number plate. It will be not only applicable for the English number plate, it can be applicable for any kind of number plate. The segment the number properly taken from different angles, that means diffuse the image, and removal of all garbage symbols obtained during segmentation. Actually, first 3 is the very common one that we can easily do that, but this is for the research work, that means how we can remove the garbage symbol. Because in real life application, always the garbage symbol will come, and we have to check it, because this is the part that we have to do. that how to eliminate this kind of garbage symbol from the NPR system. Okay. So we're planning to incorporate other parts. That means we have to incorporate the other feature like calculate speed limit of a moving car or detecting the red light violation of a car using edge computing Intel OpenVINO toolkit. So we are already doing this part, OpenVINO tools, and to extract the edge computing using the JSON Nano. Okay. So that is the obviously that is the future work. But what we have discussed here, that is the preliminary work, and only thing we have done that any kind of blurred image, if we are giving, we get the clear picture. But lot of things we have to do for our present one. So thank you. If you have any query, you may ask me.
Thank you very much, Doctor. I want to mention that this is one of the interest areas in our HPC center. We also work on the hand-printed character recognition using which can be applied to the license plate.
Right.
Mm.
That is the great area.
Yes, and there was the approach for using of the soft features, and for the for the informative feature sub-selection was applied a heuristic approach where HPC system, HPC center and the parallelized algorithm was used. I want to ask you, I see the future work which you showed. I want to ask if you are planning to work on the video recognition, so the recognition of the license plates from the videos.
Yeah. Because still we are working on the static, but actually our main objective is to work with the video streaming. Okay, so we have to take the video picture, then we have to process the frame, individual frame, we have to extract the frame, and on the basis of the frame, we have to extract it. So that is our main objective.
Okay.
So we have to move from the static picture to capture the video, then split into the frame, and then process the frame, then locate the number and crop the plate region and recognize the character. That is our main objective, that is main goal of our work.
Okay, thank you. I think that it is the opportunity where we can collaborate together.
Yeah, right.
Thank you.
Well, thank you.
And we will wait for the questions. If there is no questions, I want to introduce gratitude. I want to say thank you to all presenters, to all participants of the first day of the workshop, and also the administrative, the president of the St. Xavier's College and our vice rector, and to the invited speakers, and also the paper presentations. Speakers for the paper presentation. Thank you all. Thank you for attending of this workshop, and thank you for your cooperation. And I want to give an announce for the tomorrow. So tomorrow we will have two invited lectures. First is about the cryptography, and the second about the HPC Center of the Azerbaijan State Oil and Industry University, and another challenge in exascale computing. Also, we'll have the different presentations in the paper presentation session about applications of the machine learning, and about the problems and this approach to the exascale computing systems. Thank you very much, and see you tomorrow in the second day of the workshop. Good luck.